So the class is recorded. Let's see. Let everyone know they are being recorded. So they say I should let you all know that you're being recorded. Okay. So now today we go back to functions. We're not done with functions. So we are on linear functions and models, right? So the objective is that you need to know linear function, slope and rate of change, making and using linear models. So that's linear function. So note that a linear function is a function of the form. So this is the form of a linear function. If we go back to our high school, we used to write it as y is equals to mx plus c, right? Where this, in our case, b or c is the y-intercept and m is the slope. Are we okay there?
Yes, ma'am.
Thank you. Yes, so in the expression, so they say, so in the expression defining a linear function, the variable occurs to the first power, meaning that they say that this is to the power of 1. That's why it's called a linear function. So y is equals to mx to the power of 1 plus c, right? That is what they're saying here. It's the first power. So that's why it's a linear function. We can also express a linear function in the equation form as this one here. Okay, so this definition says a linear function is a function of the form. The graph of a linear function is a line of the slope. As we said, m is the slope in this case, and a is the slope there, and b is the y-intercept. Are we together? Can I move forward?
Yes, ma'am.
Thank you. Now, in their part, they say, so in example 1, they say determine whether the given function is linear. If the function is linear, express the function in the form of f of x is equals to ax plus b. Remember, f of x is the same as y, guys. So you will notice that in our assignments, we wrote y is equals to f of x is equals to maybe ax plus b. So they're saying that you need to determine whether these are linear functions, and if they are linear functions, write them in this case here. So let's go to the first one. Is this a linear function, guys?
Yes, ma'am.
Yes, ma'am.
Yes. Why are we saying it's a linear function?
Because x there has a power of 1.
Thank you. So they say, since you're saying it's a linear function, you say yes, and then we need to write it like this in this form. So meaning that we'll write it as f of x is equals to 3x plus 2. So we wrote it in form. All together.
Yes.
Thank you. So they say yes, it's a linear function. Okay, here they went further just to explain. They say yes, it's a linear function. So f is a linear function in which a is 3 and b is 2. So let's write it in that form. Okay, so it's written here. Now, they are also asking, is this a linear function? B, is it a linear function? Yes, good. So now since it's a linear function, let's write it according to f of x is equals to ax plus b. So how do we do that? So meaning we need to simplify. So this becomes 3 minus 6x, right? So to write it like this will be minus 6x plus 3. There we go. So G is a linear function in which A is -6 and B is 3. Is this a linear function?
No.
No, ma'am, it's not a linear function.
No. Well done. It's not a linear function because if we simplify, we'll notice that this x multiplied by that, that's 4x. This multiplied by that plus 3x squared. Now, because of this power here, it's not a linear function. It's actually a function called a quadratic function or a parabola. Thank you. So, which is not a linear function. So here they say which is not a linear function because the variable x is squared in the second term of the expression. Thank you. Is this a linear function?
Yes.
It's not.
Okay. Let's start with the person who says it's not a linear function and tell us why you're saying it's not a linear function. The person who said it's not a linear function, please tell us why it's not a linear function.
Has x squared.
Where does it have x squared? This one.
It have 3x squared.
No, this one. Number D. Looking at number D. We're looking at number D. We're looking at number D. Is number D a linear function or not, guys?
No, ma'am.
It's a linear function.
It's a linear function.
It's a linear function.
But I'm hearing no.
It's not.
Why is it not?
It's a linear.
It is a linear function.
A linear
Okay,
function.
Someone said it's not a linear function. Why? We need to fix those masters. Why is it not a linear function?
The outcome is an fraction.
There are no squares. There's no x squared or x cubed.
There you go. So there's no x squared or x cubed, therefore it's a linear function. So how do you simplify that? We know that in maths, if you have a plus b over 4, you can, because it's only one term in the denominator, or even if it's what's this? Let's write it like this. Let's write it like that. We know that if we have a plus b over, let's say x squared plus 1, then this can be written as a over x squared plus 1 plus b over x squared plus 1. So meaning that here we can write k of x is equals to 1 over 4 minus 5x over 4. From here, it's then easier to see that this is actually a linear function. So they want us to write it in terms of f of x is equals to ax plus b. So let's write that. So this is minus 5x over 4 plus 1 over 4, where our a is negative 5 over 4, and our b is 1 over 4. All together.
Yes.
Yes, ma'am.
Thank you. So k is a linear function in which a is negative 5 over 4 and b is 1 over 4. Now, is this a linear function? Let me think.
Slow.
Is this a linear function?
Yes, it is, ma'am.
Y equals to x.
Yes, ma'am.
Straight line.
The linear function.
Is this a linear function? Number 2.
Yes.
Oh. Yes.
Mm-mm.
Yes, ma'am.
Is it a linear function? Number 2. I'm hearing yeses and no's.
Yeah. Yes.
Yes, it is.
Why are you saying it's a linear function? Let's start there.
That's one.
It doesn't have x squared or x cubed.
It doesn't have x squared or what? Okay. So now let's simplify it. You're saying it's a linear function. Those who are saying no, why are you saying it's not a linear function?
So on my case, like if you can try to simplify that expression, it's going to be y is equal to 1 over x plus 1. So that 1 over x, I don't know.
Thank you very much. So the power will be to the power of 1 over x. guys, sometimes by just looking at it, because it has a power of, what's this? It has a power of 1. Remember, we said it's a linear function because its f of x is equals to ax plus b, right? So we said y is equals to ax plus b. Did you see that here there was no multiple of y here? It was just only a constant times x.
Yes, ma'am.
There we go. So if
Yes,
it's a
ma'am.
constant times x to the power of 1, then it's a linear function. You need to be very careful. Here, you see it's a variable times another variable. Even if it's to the power of 1, it's not a linear function. Are we all together there?
Yes, ma'am.
It's a power.
Yes, ma'am.
Yes. So do you see that I would have given you this in the exam, and some of you would have said it's a linear function. So now let's try to simplify it. You see, we have x, y is equals to 1 divided by x divided by x. Therefore, y is equals to 1 over x. Do you see that it's not a linear function? Because the power here is x to the power of 1, negative 1. So are we all together there?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So you need to know in the exam, some of your questions will be theory, some of your questions will be practical, and some of your questions will be thinking. You need to think like this. So now they say a slope and a rate of change, right? They say that let f of x is equals to ax plus b be a linear function. Now they're saying that if x1 and x2 are at different points, at different values of x, and if y1 and y2 are different values of y, then the points x, so then the points x1 and y1 and x2 and y2 lie on the same graph of f. Is it clear? Is the statement clear, guys, or should I clarify it?
It's clarified.
Okay, good. Let's move forward. Now they're saying, can you please mute? Now they're saying that from the definition of the slope and average rate of change, it's what we did last week. I might ask you find the average rate of change, or I might ask you find the slope, because according to this, according to what we're having here, the slope and the average rate of change is the same thing. Do you see that? This is what we calculated last week, and we know that when we were calculating the slope of a straight line, we said change in y over change in x, which is y2 minus y1, x2 minus x1, is equals to the average rate of change. Can someone mute, please? Someone there? Someone is disturbing me. Thank you. So, are we all together, guys? If I say find the average rate of change and find the slope, you're actually doing the same thing.
Yes, ma'am. It's clear.
Yes. Now,
ma'am, can you please explain just a little bit more?
Okay, so when we look at the rate, the average rate of change, it's what we considered last week in last week's class. So that's when we went through to check masters to understand and do the rates, the average rate of change. So we covered this in last week's class. But if it's something different, then masters, then I can explain. So what do you mean?
Oh, okay, no, it's fine. I was confusing the two.
Oh, okay.
I was confusing the linear one and the slope of rates of change.
Okay. So, okay, but remember that when we were looking at the average rate of change, what we did is, let's say we had a curve like this, né? And then we drew a line. Yeah, my line. We drew a line. I need to find it. Okay, let's go to wait. So you have a curve like this, right? And then what we did is that if we want to find the rate of change, meaning that, let's say if this was the distance traveled from Cape Town to Joburg, and you want to find the slope or the rate of change, the distance of change, something like that, like the rate of change from here, from this point to that point. Because the curve is not a straight line, what we did is we chose 2 points from the green curve, and then we drew a line like this, right? And then we checked for the change in y as well as the change in x. That was the average rate of change, meaning that at this point, let's say it's 0.1, and then this is 0.2, right? And we were looking for, what's this? The distance, maybe, or the speed, right? So then we said what's this? Evaluating the function. So if we're looking at, let's say, for v of t, right? Velocity or something like that. We then said, okay, fine, evaluate v of t at this point here. So then we have v of p1 minus at that point there. Then we said v of p2 divided by p1 minus p2. Then we found the average rate of change of whatever we are looking for. That's why then the average rate of change is exactly the same as the what? The slope when it comes to a straight line. Are we together?
Yes.
Yes.
Thanks.
Yes, ma'am.
So if we go back here, you'll see that they're saying, okay, now the slope is actually the average rate of change. But now something, please, you know, there are people who used to confuse this part, right? So remember when we were finding the slope of a straight line, we said change in y over change in x, isn't it? Then we had y2 minus y1 over x2 minus x1. Now, you can also write it as y1 minus y1 minus y2 over x1 minus x2. Meaning that on top, if you started with y2, you need to at the bottom start with x2. And then if you ended with y1, you need to at the bottom end with x1. Same here. If you started with y1, then this has to be x1. Are we all together?
Yes.
So you can write it like this, or you can write it like that. So we know that the slope of a linear function is the same between any 2 points. Do we know that? Do we know that?
Yes, ma'am.
Where did we learn it? From last week's class.
Last week's, yeah.
Yes, we say we know that the slope of a linear function is the same between any 2 points. From last week's class, we said that if we have a straight line like this and we choose, let's say this is point A1 and this is point A2 and maybe this is point A3, meaning that if we find a slope, if we take the points for A1 and A2 or the points for A2 or A2 and A3 or for A3 and A1, the slope will be the same. And that's what we covered in last week when actually looking for the average rate of change. In conclusion, we say the average rate of change of a straight line, the average rate of change of 2 points on any 2 points on a straight line will remain constant. So they're saying from the above equation, we conclude that the average rate of change of a linear function is the same between any 2 points. So they're saying, moreover, the average rate of change is equal to the slope. They're just repeating this part here. Are we together?
Yes, ma'am.
Yes, ma'am.
Now they're saying, since the average rate of change of a linear function is the same between any 2 points, it is simply called the rate of change. Are you seeing the terminologies, guys? Hello? Are you seeing the terminologies? So they say, since the average rate of change of a linear function is the same between any 2 points, it's simply called the
rate of change.
Thank you. Now they say the slope and the rate of change for a linear function f of x is equals to ax plus b. The slope of the graph of f and the rate of change of f are both equals to a. Hence the coefficient of x. So meaning that a is equals to the slope of, for example, if I say find the slope of this, I'm given 2 points, find the slope of these 2 points on a straight line, or maybe I say find the rate of change of these 2 points given these 2 points are on a straight line. Are we together?
Yes,
Yes.
ma'am.
Thank you. Some questions in the exams, they become difficult because you just don't if you don't know your terms, if you don't know your theory, and they just become difficult. Because if I say given 2 points on a straight line, A 1, 2, and A, let's say A2, 3, and 4, right? Find the rate of change. And someone will not know what the rate of change is because they don't know that the rate of change is the slope of the straight line. So those are some of the terms that I'll then be using. I'm just giving example of how I'll be setting the exam. Now,
Okay, ma'am.
Yes.
Okay, this scenario of slope and rate of change is all about the gradient.
Yes, it's all about the gradient. That's why you see I'm moving very quick because I know with the straight line, it's something that you've done and most people do understand. Yes, that's why I'm moving a bit faster with this particular section because the next section is interesting and nice and confusing a bit. Now, sometimes so one thing I'll tell you is that I might not ask you to draw the graph. What I might say is, for example, look at this example 3, right? This example 3, you don't see a straight line here, right? But but by looking at the example, how do you know we're dealing with a straight line here?
Because the variable t there has a power of 1.
Thank you. Do you see that?
Yes, ma'am.
So it
ma'am.
might not be just easy to say, this is a straight line if you don't know that, because a variable of t, if you look at this function here, please mute. So if f of x, for example, is equals to 4,5x plus 28. Thank you. Keep. So if you don't see it properly, put x instead of t and see, this is a straight line because the power is equals to 1. So I might give you questions like this because remember your exam is multiple choice. You see, so your exam is multiple choice unless something changes, and I will let you know that there has been some changes. Your exam is no longer multiple choice. Are we together?
Yes, ma'am.
Thank you.
Yes, ma'am.
Now there is a dam. So a dam is built on a river to create a reservoir. Now, the water level, F of T. So this is important. Water level in the reservoir at time T is given by. So if you have a reservoir, so I'm assuming it's a container like this maybe, right? Where water flows inside, right? And then they're saying that the water level F of T. So meaning that if the water is here, maybe at some point, at some time T is equals to after 7 seconds, for example, after 7 minutes or 7 seconds, then the water level will be here. Now, the water level at T is equals to 9 might not be the same as T equals to 7 altogether.
Yes, ma'am.
Does make
Yes,
sense.
ma'am.
So meaning that it's important that when you read, try to make a scenario that, okay, there's a reservoir, water is coming in, and chances that water is coming out. Remember that you can't just reserve water. It means that the reason why it's reserved, at some point it will be drained. You see, so if you're given a statement, it is important that you keep in mind of what the situation is at that point. So they say where T is the number of years in the dam was constructed and F of T is measured in feet. So let's say meters. Now sketch a graph of F. Guys, do you know how to sketch a straight line?
Yes.
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
All we let f of t equals to 0 and solve for y, and then we'll let t to be 0 and solve for x.
So it was 4, what is it? 4,5 next?
Yes, 4,
Yes,
5 plus 28.
Okay. So you say let, what is that? Y-intercept?
yes, f of t is 0. And
Okay.
then so f of t will be 4,5.
Wait, let's not confuse here. What is this that you're looking for?
Now we are
Y-intercept or X-intercept?
we're looking for y-intercept.
So if you're saying Y-intercept, you let what equals to 0?
T.
Not f of, you let t equals to 0. Do you see that?
Yeah, not the whole
Yes.
function.
Thank you. So then this is what? This is 0 equals to 4,5, 0 plus 28. So at f of t, f of 0 is equals to 28. Okay,
Okay, that's
now X-intercept. We let what now?
f of x.
F of t. Don't confuse, don't say f of x. F of t equals 0. Thank you. So then this, meaning that this is equals to 0. So then we have 4,5 t plus 28. Okay.
Yes.
Then we have that this is minus 4,5 t is equals to 28 over negative 4,5 over negative 4,5. So how many 4,5s do we have here? How many 4,5s do we have here? It should be around 6.
Negatives.
6.2.
Negative C.
6.22.
22.
Okay. Now let's go and draw. So you're saying that the y-intercept.
So, ma'am, can I ask something?
Yes, there's a burning question. That's what I wanted to say. There's a burning question. There's a very huge burning question. And can I have that burning question? Ask something.
No, I just want to ask, because since we're not allowed to use calculator, if I left that answer at it is without dividing, like, so that I can get 6.22. So if I let it like the way it is.
So in most cases, in the exam, I give you questions where you don't need the calculator. So you can't say 30 divided by 5. You don't know what 30 divided by 5 is.
Yeah, that's what I'm asking. If let's say I'm plotting a graph, so I just let it 30.5 at the point. I write it like that, not dividing, because if I divide, then I'm gonna have to use. I'm gonna be against the law.
Yeah, that's what I'm saying. That it's, for example, how many 2.5? Like for example, 30 divided by 5. We know that's 6, right? So it's easier to calculate using that. And then we know that 2.5 divided by 5 by 30, that is what's this? That is 12. So I'll make it easier for you to not use the calculator and just see, okay, 2 divided by 1 is 2. So it won't be something like that.
Okay. Thank you.
Can you please help me to? Okay, thank you for that. I'm still waiting for the burning question. So this will be f of t, and this will be t. I'm still waiting for the burning question. There's no burning question. Okay, let's plot then. How do I plot, guys? How do I plot? I know someone is a burning question, but for now, how do I plot? So I know this is negative 0.6, isn't it?
Yes.
And I know 28 has to be somewhere here, isn't it?
Yeah.
Yes. And then I draw like this.
Sorry, ma'am, can I ask?
Yes.
T is standing for number of years, isn't it?
Yes. Yes.
And we are having a negative number of years.
Thank you. That's the question I was looking for. So, okay, please mute then. Please mute.
Mosima.
And how is Musima attending class when she's busy enjoying it? Okay, thank you very much. Guys, okay, this is a way of what's this? This is a way of drawing a graph, right? Of a straight line. Are we all together?
Yes.
Yes.
Yes, ma'am.
But the burning question was that, ma'am, T weight stands for number of years. So it means that we cannot have T is equals to negative 6,28. Are we all together?
Yes.
So meaning that T has to start at 0, and we know T at 0 is here, isn't it? So it means it will only start here at 28 and go further. So meaning that we'll only have, okay, let me choose the blue color. We'll only have this top graph here. And the remaining graph, we remove it. Are we all together?
Yes, ma'am.
Yes, ma'am.
Thank you. So in the exam, I was going to give you the full graph, and I know someone would have chosen the full graph and this one. So let's go there. Now they're saying sketch. Let's see our sketch. Do you see that? Do you see that? Because our
Yes.
scenario starts from T is equals to T greater than time is always positive. So that's why then it starts from this point here and goes further like that. Now, by looking at this graph, is the, what's this? The level of the reservoir increasing or decreasing?
Increasing.
Thank you, it's increasing. Now, what is the slope of the graph?
Uh, 4,5.
4.5.
Thank you, it's 4.5. That's the slope of the graph, 4.5. What rate is the water level in the reservoir changing? Please mute. Do you see how this question is asked? What rate is the water level in the reservoir changing?
4.5, ma'am. The rating.
Thank you. 4.5. Did you all get that?
Yes, ma'am.
Yes, ma'am.
Because we said the rate of change is the slope. So meaning if they ask you what rate is, do you see they didn't ask you, they're asking it in a different way. So in the exam, I might ask you in a different way. So they're not drawing a graph and they say find the slope and whatever. Now they're asking about the rate of change. Thank you. So the graph, so the graph is aligned with the slope 4.5. That is the coefficient of T. So they're saying the rate of change of F is 4.5, the coefficient of T. Since time is measured in years and the water level, F of T, is measured in, let's say, meters, the water level in the reservoir is changing at a rate of 4.5 meters per year. Are we understanding the statement, isn't it? So if I give you a statement and say choose the correct one, you'll choose the correct statement, isn't it?
Yes, ma'am.
Yes, ma'am.
Thank you. Now they're saying since the rate of change is positive, the water level is rising. That's how we can use the straight line to answer your question. So now making and using linear models. Okay, so here's an example. They give you a linear model. So they say when a linear function is used to model the relationship between two quantities, the slope of the graph of the function is the rate of change of one quantity with respect to the other. So for example, the graph in figure 3A, which is this one here, gives the amount of gas in the tank that is being filled. So the slope between the indicated points is this one here. Are we together? Now, by looking at the graph, is the gas being filled in the tank increasing or decreasing?
It's increasing now.
Increasing.
Thank you. Now we have the slope in the rate at which the tank is being filled, 2 gallons per minute. In figure 3B, the tank is being drained at the rate of 0.3 gallons per minute. And the slope is negative 0.3. Do you see how you then use the whole linear function to actually model problems?
Yes,
Guys,
ma'am.
thank you.
Yes, ma'am.
Here's another example. Water is being pumped into a swimming pool at the rate of 5 gallons per minute, at the rate of 5 liters per minute, let's say that. Initially, the pool contains 200 assuming it's gallons of water. Find the linear function V that models the volume of water in the pool at time t. How do you do that? You see, straight lines are also important. Even if they're simple, they're also important. How do we do that? So
Ma'am, can I try, ma'am?
Yes, please.
So the equation is going to be equals to V.
Yes.
Because that's what we are looking for. And then looking at the question, it says at the rate of 5 gallons per minute. So
Okay, before that, the equation is going to be V what? V of?
V of t.
Thank you. V of t.
Okay.
Equals to A x plus
B.
B. Sorry, V of t. Why? Because they say find a linear function. Do you see that?
Yes,
so as soon as they tell you that it's a linear function and you know they talked about time, because they're saying that find the linear function V that models the volume of water in the pool at any time. So it means that T. So the function will be like this. That's your first point. Okay, continue now. Now that we know how the function will look like. So please continue.
As I was saying, ma'am, then our A is going to be 5T because they said 5 gallons per minute.
Thank you. So they didn't say 5 gallons per minute. They said what? That made
the rate of 5 gallons per minute. Yes, ma'am.
Thank you. The rate of 5 gallons per minute. That's why your A is equals to 5, because we said the rate of change or the slope is equals to 5. So now we can't talk about slope. We can talk about the rate of change. Okay, then?
And then the pool contains 5 gallons of water. I guess that's going to be our B. That's 200 gallon, ma'am. Sorry.
Why are you guessing it's going to be our B?
I don't know, ma'am. The pool contains...
Okay, the pool contains 200 gallons of water.
Water, yes, ma'am.
And 300, the pool contains. And then the pool contains, I just want to add a statement because that's what I can do in the exam. Okay, the pool contains 200 gallons of water, right? And 3,000. I can use the same question and just add a statement. And 3,000 gallons of water after 7 hours. Now the statement changed. So you're going to, now there's 200, then there's 3,000.
Then you must add them both.
Eh?
Hey, ma'am, you are confusing us now, ma'am.
Yes, that's the aim.
Ma'am, I
That's the
think
aim. Yes.
that 300 gallon we're gonna have to consider it on the new equation, because they said after 7 hours. So we firstly have to find the volume of the water first, and then after 7 hours, then we can calculate that. We can maneuver around the equation, man.
Okay, so now give me now. What's the equation now? I know there's someone sitting there and has answered. Guys, whether it's wrong or right, I know it's in your heart. Someone has the right
Then we
answer.
can solve it.
Okay, we can't solve that. Another one? Guys, you remember in...
Ma'am,
Yes?
don't we make the B, don't we substitute that for the time variable?
Close, but not your, it's like you are eating the pap. I tell you to cook the pap and you are eating the pap. So who cooked the pap? So let's start with cooking. Let's start with cooking. Oh Lord, what have I done? Yes, I said something. Hmm?
Can I try?
Are we
Yes.
gonna?
Wait, the lady, can the lady try first?
Since we are given that there are 200 gallons of water in the pool at time t, at t0, our V is going to be 200 equal to A, open bracket 0, close bracket plus B. Then we can solve for B and we can find that B is 200.
Okay, I'm giving you 3 minutes. She said something there. She said something. Can you discuss? I'm giving you 2 minutes. I'm coming back. Please discuss.
Oh, yo. Yeah, what to discuss?
Yes, let us discuss, guys.
Okay, yeah. Let me start there. Like the way I understand this question myself, we've been given the water is pumped into a swimming pool at the rate of 5 gallons per minute. Initially, the pool contains 200 gallons of water. Number A, find the linear V that models the volume of water in the pool. Okay, first we have to identify that the initial volume of the water in the pool is 200 gallons. Is the given information there?
Yes.
And then number two, I think we have to determine the rate at which the water is being pumped into the pool, which is 5 gallons per minute, I guess. And then, are we still together, guys? And then number three.
Yes, we're together.
We write the linear function V that models the volume of water in the pool at any time. That is the equation. V is given by 5t plus 200.
Yes.
And then,
guys, our f at x is it not equals to 200?
I sort of agree with him, because if V is the volume of water, they've already told us that there's 200 gallons and there's 300 gallons. I think we should substitute the V for the gallons of water that we are looking to calculate.
And then like to find out how long it takes to fill the pool at capacity of 600 gallons. I think we have to let V, the f of V is equals to 600 to solve it.
No, how do we arrive at 600? At 600.
Okay, before that, right?
Because of y,
Okay.
I think our
Wait.
y is equals to 200.
So before that, right? Let me show you something. And I said 200 gallons in after, let's say 300.
Before you say something, can I say there's something that it's pretty interesting, particularly on the statement that you have added here. So initially on what you have been given on example 4, we are given 200 gallons of water at a pool rate time T0. So on the second statement that you have given us 3,000 gallons of water at and you have given us the time, which is 7 hours. So I think what we need to find in order to solve the equation is to get the rate of water put into the tank per gallon per minute, since all you have given us the gallons, and you have given us the number of hours. So I think in relation to those two, we have to find the rate. I think now what we need to find on the second part, it's the rate.
Can someone, okay, I'm giving you what you just said right now. It's perfect. But can someone say what they feel about the statement that has been given? He's saying that we need to find the rate. Can someone help there? Everything is perfect. Yes.
But
I
the
need
rate
that burning question.
the rate is already given at 5 gallons per minute.
Thank you.
Yeah.
And the other thing, even if the rate was not given at 8 gallons per minute, where are you going to substitute these gallons? Because you do not know your V of T such that you can have V of 200 minus V of 3,000 or 300. Does it make sense?
Yes.
So meaning that the statement is correct, but where are you going to substitute so that you can find the change in V of 200 minus V of 300 over 200 minus 300. You do have the 203, but you do not have the V. Now, you know how, yes?
So
let's do the question.
I think the only thing that we do not have looking at this, it's the B, ma'am. And we can actually find the B because we have T0. And then I think we can go from there if you've got from T0, ma'am.
All right. Okay. The reason why I said, Lord, what did I do? Because I gave you the answer there. Okay, let's not look at the question. Now, one thing, let me tell you. Remember, for financial maths, we used to have like long, like a long paragraph, right? For financial maths, if we take it to grade 10, 11, 12, especially grade 12, we have like a long paragraph, ne?
Yeah.
Not every value in the statement forms part of the statement, guys. Okay.
Me, I'm troubled when I have to find the equation from a word problem.
Yes, we'll look at that because that's part of chapter 3. I mean chapter 4. That's part of our work in chapter 4. Yes. Okay. Now let's start. We said this is a linear function, isn't it?
Yes.
Right?
Yes.
So meaning that it has to be in the form of VT. Can I use X instead? Yes or no? And why? Why am I using T? Why are you forcing me to use T? Because?
Because of time.
Because we are used
because of time. Because of time. That's why we are forced to use t. So then I know that this is a linear function. So it means that I have to have v of t is equals to a of t plus b. Ne?
Yes.
Okay,
yes.
let's not answer questions, guys. Let's not answer questions. Because if we answer questions, we'll be confusing ourselves. Let's not answer questions. This is how I want you to start thinking. Right? Okay, I have v of t
equals to a of t.
Thank you. V of t is equals to a of times t plus b. Now, if I'm sketching the graph, right? What do I say? The y-intercept. Before the y-intercept, we know, okay, before that, we know that a is the rate of change, the slope, isn't it?
Yes.
And we know b is what? Please mute.
B is 200.
Sorry, please mute. We know that b is the y-intercept.
The y-intercept.
Now let's sketch. Let's assume we're sketching. So let's find the slope. Okay, the slope, we take it from the equation. We know it's a, right? That's the slope. Good. Now, we know b is the y-intercept. How do we find the y-intercept? Y-intercept. What do we say? We say let
T equals to 0.
Let t equals to 0. V of 0 is equals to a. Let t equals to 0. B. Therefore, v of 0 is equals to b.
And the v of 0 is 200.
Why?
The initial one.
Thank you. Because t is equals to 0. Are we together, guys? Are you seeing what my point of doing this?
Yes, ma'am.
Yes.
Yes, ma'am.
Thank you. So because you know initially, if we look at our straight line, let's go back. If we look at our straight line, this one, it's in time. So the y-intercept will be the point initially, t equals to 0. We say y-intercept, let t equals to 0. And then where do we know that, okay, now, even if I can, please mute. Even if I can put a statement of saying 300 gallons, but the question says initially, meaning that a t equals to 0, and we know that when we have v of t equals to at plus b, t at 0 is the y-intercept. Therefore, it means that our b is equals to what? 200.
200.
Did you see how I got it, guys?
Yes.
Thank you. So therefore, our v of t, rate of change is 5. So that's 5t initially, meaning t at 0 is equals to plus 200. Even if you had another statement there, it wasn't going to affect because they told you initially that is equals to that. Are we together?
Yes.
Yes.
Now it's clear, ne?
Yes, it's clear.
Yes, ma'am.
Thank you. So now they say if the pool has a capacity of 600 gallons, what do they mean then?
That means the V of T is equal to 600.
Thank you. V of T is equals to 600, right?
Yes.
How long does it take to completely fill the pool? What are we looking for?
We are looking for T now.
Thank you. Please mute now. When they ask you for how long, it means we're looking for time, right? So they're saying that, this is the statement, because someone asked, why do we equate to 600? They're saying that I have V of T, and I substitute some value of T equals to, please mute, guys.
Mute.
Who's There's a hand, yeah.
I think it's area numero.
Yes, this is.
Yes, what does the hand say? Guys, if you raise your hand, I can't see. I'm sorry. You see, I only see like this. I can't see. Can the person with the hand? Yes, what's the question?
It's Humbulani.
Humbulani, what's the question?
Sorry, I heard you saying that in the exam we don't use a calculator.
Yes.
Okay.
For me to change, it means I have to go and ask in the university. It's a long process, but then it has been that students are not using calculators for Math 1510. You see, so questions will be easy to solve without using a calculator. I'm not saying easy to solve, but easy to solve without using the calculator. Now, it says if a pool has a capacity of 600, how long does it take? So meaning that they took this equation and substituted some t inside that equation. Let's say some t is t, right? Or let's call it the name plus 200, and they got 600. That's what they're asking. So meaning that they want you to find t. So meaning that you have to solve that. So this is t equals to 600 minus 200, and then 5t is equals to what? Is equals to 400.
400.
And then over 5 over 5. So t is equals to what?
80.
80 minute. Remember, your units are important. 80 minutes. There we go. There we go. Since the pool contains 200 gallons to begin with, initially, therefore, B is that. Now that we know A and B, we get the model, and then we want to find the time t at which V of t is equals to 600. So we need to solve this. Solving that, we found that it, and then that's the end of the first session, first section chapter.
So, ma'am, is it because I think one thing that's going to confuse us is the fact that they are using American merits, ma'am. So, can't we have South African merits, ma'am?
But you have seen me when I was saying time, minutes, meters, and feet. You have noticed I've been doing that, isn't it?
Yes,
Yes, I have noticed, ma'am.
Yes, so I'll be doing that in the exam as well.
Okay, you can write minutes there in the time.
Yes, minute. So it takes 80 minutes, yes. Okay. So sometimes I might not say T is equal to, I might say, so it takes 80 minutes to fill the pool. So it takes, remember, it's a multiple choice. So it takes 80 minutes, so it takes 70 minutes, so it takes 50 minutes. And then I do that average rate of change of people because I know people will do that. And then I put it as one of the solutions.
What if I say it takes 1 hour and 20 minutes?
But then remember that you'll be choosing from the given solutions. So 1 hour and 20 minutes won't be in the given solutions. So your exam will be like your assignment 1, basically.
Okay.
Assignment 1 in 5, yes. Okay, you see this one, eh? Don't save. This one needs us to breathe. This one, it needs us to breathe. It's one of the questions. It's one of the things that are there in the. It's like I am not going to ask it. I have to ask it. Are we together? This section. Ne?
Yeah, that one. Hey.
And it's there in the assignment, ne?
Yes, ma'am, and you made it.
So that's why I'm saying I'm not going to. I am not going to. So I'm negating the not, so meaning it's positive. I'm going to ask it, right? One way or the other. Okay. So transformation. This one wants us to breathe. Are you breathing?
Yeah.
Yeah.
No, we're not, man. Not breathing, man.
We are breathing.
Hey, people,
and you skip this one in the exam, please. Just have mercy.
If I skip this one in the exam, it means that I'm creating teachers and a lot of like different, because this MAT1510 is consists of a lot of people. A lot of people. Now, meaning that
Giving
you
us
won't be able
stress.
to, as a teacher, you won't be able to sketch the graphs and explain to your learners. As someone who's in what's the other I noticed? If you're given data and you're sketching the graph and you need to be transforming the data by just adding values and whatsoever and subtracting and whatever, then you won't be able to do that. Then we'll be having burning bridges. We'll be having teachers who can't teach. We'll be having a lot of. It's very important. Let me just say that it's very important. So I can't skip it. I'm stressing it because I know it's there in the exam. I know I'm going to put it in there. It has been there in all of the exams, so I'm going to put it definitely. It's there in your assignment. So transformation of function that starts. Now the objective is that you need to vertically shifting, horizontally shifting. You need to reflect the graphs. You need to vertically stretch and shrink them. You need to horizontally stretch and shrink them. And then you need to know whether a function is even or odd. In this section, we study how certain transformations of a function affect its graph. Are we together?
Yeah. Yes.
This will give us a better understanding of how to graph functions. Now, the transformation, yes?
Is transformation of function in the textbook or using...
You see everything? Yes? Sorry, finish your question.
No, I'm saying because it seems like it's a slide. It's from the textbook, like the prescribed one.
Yes. Disclaimer, these are the exact slides that are provided by the people who wrote the book.
Okay.
Yes, so meaning that if you go into the textbook, there's more, right? Here they're just summarizing what you need to learn and what. So you go to the textbook, there's more, and then you do the odd questions because they have answers at the back. You see, and if you are doing those odd questions, remember I said the work that I'm going to set, it's not something new. It can be a question in your questions from the back, even and odd, and even after the exam, we can even meet and I tell you this question is the same as this question. This question is this question. This question is that question. So if you don't read, like right now, you have plenty of time while you are prepared. You are doing your assignment. Plenty of time to read, understand, ask me questions, because then we'll have to go through a past paper before the exam, and I hope you'll be ready.
Ma'am, can you kindly get back to the previous slide of the objectives?
Mm-hmm. So the objectives are also there in the study guide as well. You see? They're there in the study guides as well. One thing so yeah, let me not give too much. Yeah, I'm giving the entire exam. Yeah.
Please help.
Give us now.
I'm giving, and trust me.
Give us now.
Yeah, so I'm telling you how I ask. This is how I'm asking my questions. It's not something I'm asking you. I just want you to think. You know, just think.
You see, the assignment had me thinking, ma'am. You
saying?
The assignment had me thinking on this transformation.
Yes, we have to think. Like, math is so fun. It's like someone put an open bottle like this other day to me. It was with water inside. I don't know how to draw, so I'm sorry. So the bottle was open and had water. And they said to me, put this bottle upside down and you don't spill the water. Or the cup upside down and you don't spill the water. And they'll give me like 100 rand. I'm like, yeah, I don't have 100 rand right now, but hey, I sat there, guys, and I didn't know how to do it. Imagine a cup filled with water, and they say, put it upside down. How would you do that?
Impossible. Use a paper towel.
We can close with the toilet paper.
You don't close paper. There's a cup. Here's the cup. Put it upside down.
And so, ma'am, is this like on some sort of graph?
Oh, ma'am, maybe drink the water first, ma'am.
Okay. Can I please say who said it?
Me.
I know I'm saying who said it. Like who said I should do this? It's a grade R learner.
Grade R learner. But drink the water now.
I know he didn't have 100 rand, but yeah, he said he would give me 100 rand.
So you're cheap.
So man, did you win? Did you win?
I didn't win. I didn't win. So that thing is one of the things, I don't know where he landed, but when I looked at it, I said, this is a good way of thinking. You know why? Here's a cup. Okay, let's go back to cups. This is a good way of thinking, and teach yourself that, because when we are being tested skills of critical thinking, they want us to think like this. They're no longer saying thinking and whatever. Critical thinking is one of the skills. Here's a cup, and it's filled with water. Now, this great R learner says to me, I will give you 100 rand. I know he didn't have 100 rand. Number one, the first thing that anxiety said, whether it's anxiety or the feeling was like, this person doesn't have 100 rand. So it might not be as easy as it is, right? And then guess what? I said to him, do it and I'll give you 100 rand. I ended up giving 100 rand. Guys, I lost 100 rand. So this is how it was done. Ne? Isn't that they said we put it upside down, right? This is how the child did it. He picked up the cup, right? And he said he picked it up and he moved it up and said up, side, and then he put it on the table down.
Empty.
No, he didn't flip it. He picked it up and said that is up. He moved it to the side while it's in his hand and then put it down. Okay. And that is called up.
So you can put.
That's shifting.
Yes, he was shifting. So it was up.
You are shifting up 2 units.
Yes, he picked it up. He shifted it to the side while it's still up, and then he put it down to the table. So that was upside down.
Yeah. He was using translations, ma'am.
So I lost 100 rand, by the way. So yeah.
He was using transformations, ma'am.
Transformation. I know it was a revolution because to me, I was like, oh Lord, what just happened? That is transformation. He just moved it up, and then said left, and then put it back down on the table. So it's important to then think. That's why I'm saying you'll end up being tested by people, by kids from grade 1, 2 up to 12. And then if your critical thinking is not there, then you're having issues. And they say, yo, yeah, hey, yeah, I got you there. So let's move back. Now, the transformation that we study are shifting, reflecting, and stretching. Vertical shifting is what he did. Up or down. That's vertical shifting. So if you're shifting something, let's say it's here. Vertical, it means you're moving it up or you are moving it down. Are we together there?
Yes.
That's the up part.
Yes, ma'am.
Adding a constant to a function shifts its graph vertically upwards if the constant is positive and downwards if it's negative. Are we together?
Yes.
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 So they say in general, suppose that we know that the graph of f of x, y is equal to f of x. How do we obtain from it the graph of? So they're saying we have this graph and we want to get this graph. What did we do? It means that we moved. Now considering a is positive, meaning that a is 2 or 3 or 4 or a half, but it's positive. Meaning that if we add 2 here, we have moved this graph of f of x 2 units up. But if we subtract these 2 here, we have moved the graph 2 units down. Are we together?
Yes.
Yes.
Now they're saying the y coordinate of each point of the graph of f of x plus c is c units above the y coordinate corresponding to the point of this graph. So which one is changing? In this point, x and y, which coordinate is changing?
The y coordinate.
Thank you.
Y.
So we obtain the graph of y is equals to f of x plus c simply by shifting the graph of y equals to f of x upwards, c units. Simply we obtain the graph of this shifting downwards, c units. Now there's this one here. You see this says vertical shift of the graph, right? Suppose that c is greater than 0. That just means that c is positive. To graph, okay, last year I took it exactly like this, guys. You see how the question, you see how I said, suppose that c is greater than 0. To graph the function of this, shift the graph of f of x, and then I change here downwards. And then I said horizontal. I mean, say to the left, then say to the right, then say to the what. It means that you have shifted the graph horizontal. That's how I changed. And I said, choose the correct answer. Does it make sense on how I can ask the questions as well?
Yes, ma'am.
Because I said for vertical, if you want to vertically shift the graph, suppose that c is greater than 0. To graph f of x, this means that you have shifted the graph downwards, upwards, c units, and whatever. That's how I did the question. And believe it or not, there are people who got it wrong. So they said to graph this function here, shift the graph, the original graph, c units upwards by c units. And then to graph this, shift the graph of this c unit downwards. Are we all okay, or should we go to an example so that we understand it properly?
Yes, ma'am. We can go to the example.
Example, please. Example.
There we go. Now, when it comes to shifting graphs, right? You need to know what we call mother functions. Okay, I call them mother functions. I think they call them parent functions, right? What is the parent function of a straight line? It's y is equals to x, right? Parent function of a parabola, it's x squared. Parent function of a cubic, it's x to the power of 3. Parent function of, okay, what else do you need? Parent function of an absolute value function. Isn't that we are covering absolute value function? It's just this.
And hyperbola?
Do you see that, guys?
Yes, ma'am.
And then what else? Parent function of a hyperbolic function. What am I saying? It's not hyperbolic. What do you call this function, Gonja? It's not a, is it a hyperbola?
Exponential. Yes. It's a hyperbola.
Thank you. Hyperbola. Then parent function of an exponential. Okay, let me not do this one, guys. It's chapter 4 of our work, this one. Let me not do the last one, the exponentials. We'll come to it. It will waste our time. Yes? Is there a question?
Oh, okay,
yes.
ma'am. Continue.
There's another one. There's this one, square root of x. Do you see that one, guys?
Yes.
So if you know how to draw these ones, then you know how to draw every function by using transformation. So we know that, okay, let me draw them fast. We know that, okay, I won't ask you to draw this one. So we'll leave this one out for now. So let's go and draw those parent functions because you will need them. So you have y is equals to x. We know when we draw y is equals to x, it's something like this. So this is y, this is x. Thank you, it goes through. So this is y equals to x. Are we all together there?
Yes, ma'am.
Yes.
I'm moving fast. Y is equals to x squared. Like this.
It's upward. Spray. The parabola spray.
Thank you. There we go. So this is y equals to x squared. Are we together?
Yes, ma'am.
Yes.
Thank you.
Yes, ma'am.
Then we have y is equals to absolute value of x. Yeah, I don't want you to see you doing tables. So this is the absolute value function. All together.
Yes.
Yes, ma'am.
Yes, ma'am.
Then we have y is equals to root of x. Those are the functions you need to know.
There you go. Mm-hmm.
Are we together?
Yes, ma'am.
Yes, ma'am.
This one, if you look properly, it's there in your assignment, but I won't tell you where. In assignment 2. And I won't give you a clue. Should I give you a clue?
Yes.
Please, ma'am.
Please.
You see where they say restrict the
Yes.
function such that this function does what not.
Oh, it's part of restrictions, ma'am. It's fine,
Yes. Yes.
ma'am. Now we know, ma'am. Thank you.
Now you know, ne?
And now we
Good.
know, ma'am.
Yes, ma'am.
Yes, it's part of where they say restrict. At some point you'll be restricted, because remember what we were doing. We had y is equals to x squared, and we restricted that function. So they say restrict this such that it's a what? It's yeah. Now you have a clue, and the clue will be finished when we finish the 2 remaining chapters. Thank you. Okay, so now let's go back. Now, the parent isn't that now you are good with parent functions, isn't it?
Yes,
Guys,
ma'am.
you are good with parent function, isn't it?
Yes,
So this
ma'am.
one.
Yes, ma'am.
So they say use the graph of f of
Yes,
x
ma'am.
equals to x squared to sketch the graph of each. So let's start with this one. The first one, we know it's a parabola, isn't it?
Parabola, yes. Yes, ma'am.
So this is, okay, I like different colors, guys. So this is, okay, let's draw there.
Original one?
In my other class, they choose which color they want to use. Do you want any color? Every week we can choose a different
black
one.
this week, ma'am.
Black. Or you also
Yes,
choose,
ma'am.
okay, it's fine. So then, I'm not good with drawing, guys. My human is like this. That's how I draw a human. So I am not going to even suffer. Okay. Y and x, right? This is f of x equals to x squared. Isn't that what they said we should draw?
No.
I mean, we should use, right?
Yes, we use this one too.
So they want x squared plus 3, and they want x squared minus 2. Okay, let's go with x squared. So they want us to draw g of x is equals to x squared plus 3, isn't it?
Yes.
Yes.
Now look at this. This one is easier compared to the next one that we're going to do. So this one is saying that I have f of x, ne? F of x, isn't that it's equals to x squared. Now I have this new function g of x, which is x squared plus 3. It means that I went to g of x and I said f of x plus 3. And I know f of x is equals to y of f of x. So meaning that f of x is the y value, isn't it?
Yes.
So where am I adding? I'm adding on the y values of f of x. Okay? So let's come to this point here. Let's say this point is 2. Negative 2. And if you substitute negative 2 in here, what do you get? We get 4, isn't it? And you substitute positive 2, we get 4 here. And now they are telling you that, okay, fine. On f of x, which is x squared, add 3. Meaning that on the y value of the new function g of x, add 3. So if the point was 2, negative 2 and 4, the new point will be what?
You're gonna be negative 2 and 7.
Thank you. So meaning that the new point will be here. Negative 2, let's say 4 is here. So 7 will be here. Why am I going far? Okay, let's say 7 is here. So negative 2 and 7 will be there. Are we agreeing on that?
Yes, ma'am.
Yes, ma'am.
Now, if the point was 2 and 4, meaning the new point here, you add 3 is what? 2 and 7. So it's here. 2 and 7. So what you're doing is if you are taking every point and adding by 3, meaning this point here, right? It's y value, you are adding by 3. So it will go up here, somewhere here. This point here adding by 3, so it's going somewhere up there. But it's 0, isn't it? 0 and 6. So if you're adding by 3, that will be 0 and 3. So meaning that your parabola will shift from here and it will come here. Now, how did you draw the new parabola? So the new parabola is like this.
It's going upwards 3 units.
Thank you. It means it has moved 3 units upwards.
Oh, absolutely. Yes.
Do you see the shifting, guys?
Yeah, I got it.
Yes, ma'am.
Yes, and please make sure when you're shifting right here, this was f of x, and this was g of x, because we mark your graphs, isn't it? Unlike, it's not the same as in the, yeah. Now, what was the other question?
This f of x equals to x squared 2.
So meaning f of x is equals to x squared minus 2, ne? Let's do that. So they're saying f of x is equals to x squared minus 2, but it can't be f of x. What is it?
Oh, is it another?
H of. Thank you. It's h of x because they gave us that f of x is equals to x squared. So meaning that to us to get h of x, we take f of x and add and subtract 2. So meaning that it's f of x minus 2. Meaning for every value of y, we need to subtract 2. So this is y, this is x. I forgot that we're using a black color. So this is f of x, the parent function. You always start with the parent function. So this is f of x equals to x squared. Now, meaning that if you shift this 0 and 0, 2 units down. So if you have 0 and 0, the y value, you shift it 2 units down, that will be 0 and negative 2. So meaning that this point comes somewhere here where it's negative 2.
Yes. Turning point.
Right? Yes. Meaning that the y value here, let's say there it was, let's choose that one, negative 2 and 4, and negative
2 and 4.
Negative 2 and 4. Meaning that if we shift, positive 2 and 4, if we shift it down, this will be, if we shift it down by less negative, this will be negative 2.
Negative 2 and 2.
2 and 2 now.
Thank you. It'll be 2 and 2. So it'll be somewhere here.
Yeah. And the negative
It's
2.
Thank you. And then here it'll be negative 2 and 2. Meaning that every point we're shifting it down. So from just these 3 points, we can be able to draw our parabola. And you see that our parabola will look like this.
Mm-hmm.
Are we all together with the shifting?
Yes.
So that is vertically, meaning up or down. That's vertical.
About the importance of the arrow from the original graph to the new one.
The important?
Yeah, can I use the arrow again to show, like the one you use in the example the back for?
Arrow how? Like f of x? Please remind me.
Oh, I saw in your example somewhere back there, there were arrow indicating that the graph moved upward, or because it's, for example, showing up how it went.
Let me go. Arrow how? Where?
So no, type the one in the original type the statements there.
In the original statement. Oh yes, yes.
Graph.
I see what you mean. Okay, let me go there. Keep. Okay, now I'm confused.
I mean, this arrow between the graph, two graphs. This arrow.
The arrow. So the arrow is just showing that it's increasing or decreasing. You don't have to indicate it, right? But what is our indicator? Normally we indicate using this.
Oh.
Yes. The equations, just yes, basically.
Because I was concerned with C in that arrow. They just put arrow and C.
Yeah, no, the C is just showing you that the graph has been moved up by C units or down by C units.
Okay, I don't have to include it in the exam.
No, you don't have to.
Okay.
You don't have to, yeah. You see, even me when I was drawing here, I didn't do that. I just showed the discharge. You see, I just showed that this is G of X, this is F of X. Even here, as I said, this is F of X, the red one is G of X.
Or just mention the graphs only.
Yes, it's important you mention the graphs. Okay, here are the graphs. You see what we got there. They mentioned the graphs. You see that this one, they mentioned the graphs.
Yes. Okay.
Oh yeah, what am I doing? They just mentioned the graphs. You see, they didn't put arrows here.
Oh, okay.
Observe that this is the same as that. We explained that part. So the y-coordinates of each point on the graph of G is 3 units above the corresponding point of the graph of F. This means that the graph of G, we shift the graph of F upwards by 3 units. And the other thing is, this is how you explain. I can give you an equation like this, and I'm saying explain the transformation. Then you'll do that. Shift the graph of F upward by 3 units and shift it to the left by 7 units and shift it vertically. Yeah, I can ask you to do that.
Now that's came to play.
You say?
I mean, that's where critical thinking came to play now.
Yes. So that's what I'm saying. You need to. Similarly, the graph of H, we shift the graph of F downwards 2 units as shown in the. Yo, you see this one, guys? It showed me flames when I was doing it somehow at some point in life. It showed me flames. You say with horizontal in it. Listen and listen carefully. Right? With horizontally shifting, and if they say +2, they mean shifted to the left. If they say -2, they mean shift. Basically, they mean the opposite of what you're looking at. Are we clear, guys?
Yes, ma'am.
With horizontally, they mean the opposite of what you are looking at. Remember, with vertically, when you were adding, you know I go up. When you are subtracting, I go down. Right? With vertical, when you are adding, you go to the left. When you are subtracting, you go to the right. Suppose that we know that the graph of F of X is this. How do we use it to obtain the graph of here? So which value is changing here, guys? Now, Y or X?
The X value.
Thank you. The X is changing. So the value of F of X. Okay, so they're saying the value of F of X minus C at X is the same value of F of X at X minus C. Since X minus C is C units to the left of X, it follows that the graph of F of X minus Y is just the graph of shifted to the right C units. Do you hear that, guys?
Yes, ma'am.
So they're saying that this point is C units to the left, but the graph is actually, when you substitute this point into the graph, it's just the graph shifted to the right C units. The point is C units to the left, but the graph is C units to the right. Similar reason shows that the graph of this X is the graph of F of X shifted to the left. So we're adding here, so this will be to the left. Now the following box summarizes that. They say if C is positive value, C can be 2, 3, 4, positive half or whatever. To graph this F of X minus C, shift the graph off to the right by C units. There's a negative, shift it to the right. There's a positive, shift it to the left. Are we all together, guys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. We go. Very girl. Okay, so let's draw our graph. We know the parent function. So this is what? This is y, this is x. Let's draw our graph. Looks like this. Okay, please remember these so that we are able to draw them with different colors. Me, I like different colors. It's x plus 4 squared, x minus 2. Okay. Sorry. This chart. So this is, they say f of x is equals to x squared. And then let's say they say g of x is equals to x plus 4 squared. And the other one was h of x is equals to x minus 2 squared.
Good.
Okay, let's choose the black color because someone asked for the black. Let's start with g of x. Remember, horizontal shifting, you're shifting to the left and to the right, not up and down. So meaning that we know that g of x is the graph like this. Sorry, f of x, thank you. F of x is equals to x squared, right? No? Now let's go and choose like 2 points. We know this is 0 and 0, right? This is 0 and 0. And let's choose 2 points here. This point will be negative 2 and 4. Okay, I like choosing negative 2 and 4 because it's easy to multiply by half and get an answer without the calculator. 4. Now they're saying this one. So what do you think happened here, guys?
No.
They shifted to?
To the left.
Shifted to the left.
The left.
So which values are shifting then?
The x values.
X values.
Thank you. So give me the new points.
Okay, it's
8.
gonna be
Positive 8.
Right.
Positive
No,
8.
It's
No, it's minus 6.
It's minus
minus
4
6.
and
minus
it's minus 4
It's minus.
Guys, there's
It's
so many
minus 6
answers.
and
I'm
4.
confused.
No, ma'am, it's minus 6.
Ma'am, our
minus
value
6 and
is
4.
Minus 6 and 4.
X will be minus 6.
Okay, please, guys. I'm not on the stage and singing. It's not a concert. Okay, let's start with one person. One person.
Minus 6 and 4.
You know when Beyonce or whoever is singing on the stage, everyone's like, yeah. Yeah. So now let's start with 1. Okay. Which point becomes minus 6? I need to know.
And 4.
Which point?
So the one of negative 2 and 4, ma'am.
So it becomes what?
Negative
minus
6 and 4.
Okay, it becomes here. So it's negative 6 and 4. How do you get negative 6 and 4? Please tell us that so that we all know.
4.
Negative 2 minus 4 is equal to negative 6.
Why are you minusing 4? Because here it says x plus 4.
Ma'am, I need it changes, ma'am. Okay, negative 2 plus 4. Negative 2 minus positive 4.
No, it's not gonna change like that.
Ma'am,
Yes.
is shifting to the left by 4 units.
Thank you. It's shifting to the left by 4 units. I wanted to see if you were thinking critical. Okay, so because here it's changing the x values, and remember I said with horizontal, anything that is horizontal, it's a bit confusing. Do you understand? So it does the opposite, because here it says I'm adding, right? I'm changing the x, but because we said if you're adding, then you need to be what? You need to be subtracting when it comes to shifting your graph. So only the x values are changing because here you are changing x. So meaning that at negative 4 minus 4, minus 2 minus 4 is what? Minus 6. This point comes go up here. And then this point becomes what, guys?
2 minus 4 equals
2.
Minus 2 and 4.
Thank you. Minus 2 and 4. So it comes here.
4.
Then the origin becomes minus 4 and 0.
You guys are
the point is 0, minus 4 and 0, yes.
So this one is minus 4 and 0.
Yeah, and the turning point.
Ma'am?
Because you say...
Why am I confused now? So the turning point, okay, you have...
point.
No.
Horizontally.
Sorry. I'm still shifting it vertically. I'm sorry. Hey, come back.
We are shifting it horizontally, ma'am, not down, up.
Okay, let me breathe. Remember, I said we need to breathe in this one. Okay.
Let's use a different color, yes.
Yes. Okay. Let's go back. So we are shifting it horizontally, not vertically, right? So meaning that the x value is the one changing. So the x value will be somewhere somewhere here.
-4.
At x is -4. So it's here.
No, ma'am, on the line.
No,
on the line.
What am I saying?
It's a region.
Guys,
ma'am.
let me go drink water.
Yeah. Breathe, man.
Because I don't know what
we are drinking water. What about us on exam? Yo.
Think about thinking about that point, eh? Zero minus 4 is -4. We're dealing with x-axis rays.
She's not there anymore. She went to drink water.
My best friend.
Now I understand why she said we must breathe, because you'll be in the exam, you'll be shifting left, right, center. Yo.
Hey guys, is the class start at 11?
Yeah, it started at 11.
Okay, thank you.
So guys, will there be a recording of this class?
Yeah, it's recording.
Yeah, the recording is going to be there. And guys,
Okay, thank you.
Guys, the exam is going to be a multiple choice only, or maybe there's going to be the combination of multiple choice and some questions.
Multiple choice. She'll tell us when it changes.
Okay.
Yeah, guys, I've heard that last week there was a class. So, guys, please do send what you call on all the groups the link so that we can all attend, because of you see there was a class last week and we didn't attend because of we didn't know, we didn't get any link, and we are all
just go up
in
here.
those groups.
About that, my brother, man, even
there is a class on your announcement on my module, or you can go on YouTube and say Anastasia Tlamini, you find the class.
No, I found the class every Thursday.
So the class is every Friday or every Thursday?
Every Thursday.
From
Every
11.
Thursday.
Oh.
Every Thursday, 11 o'clock.
But others on a WhatsApp group, they are complaining about the class, or they attended the wrong class. Is it possible to attend the wrong class?
I'm also group that are facilitated by Madam Marlis, that is a facilitators groups. This is where the lecturer is giving us lessons. So if you are not sure which one to attend, you choose whether you want to go to the e-tutor or to the lecturer. It's your choice.
Oh, okay.
Okay.
So what you say? You see that we have Mr. Madimbo is a tutor or is a lecturer?
Is an e-tutor, is a facilitator. That's why when he's leading the class, you tell you, I'm not here to teach you, I'm here to guide you. Whereas ma'am is telling us what's going to be on the exam, because this is her module. She controls it. Those ones are just helping us academically.
Oh, because I was confused because now the other one there's a class you'd find that when you join is the guy that is busy there is Mr. Madimbo. And now on the other guy, because this is the first time I'm attending because I thought maybe Mr. Madimbo is the one of the lecture of the module.
Dr. Anastasia is the owner of the module. If you go on my module, then you check, you'll see that she's the lecturer.
So Mr. Madimbo is just a tutor?
Yes, even Mr. Malaji also.
Oh, okay. Now I understand. Because I was like, what's going on? I'm moving two people. Yeah, okay. No, thanks.
Oh, I heard about the WhatsApp group. How do I join it?
I also like to join the WhatsApp group, please.
If you go on Teams, you go on the recorded classes, you find that they are like, you just like quantitative analysis, you click there, you see that there is messages and recordings. You go scroll up, you find links of for Dr. Cave, Taboseng, Dr. Mdimbu, and Mr. Malaji groups. You find them, they're all facilitated by Madam Marlis. So you just message her and then she'll add you in the group.
Okay.
Guys, I am back, but I don't know what's going on with this thing because now my screen. Okay.
How are you feeling, man? Breathe.
I'm breathing. I just don't know what's going on. Now my computer wants to breathe as well. Can you see my screen?
Yes.
Yes. It has frozen. It's frozen. Look at this. I don't know what's going on. You see, Teams is frozen on my side. I don't know what's going on. I can't click anything. I can't do anything. So I'm doing the.
Maybe you need to refresh.
But if I refresh, then we will waste time. I want us to come back here.
Oh, here you go.
Yeah, you can see the screen.
We are making business.
Oh, and Humblani will be the star now. Look at this. Your picture doesn't want to disappear. Okay. Please bear with me. I think we'll have Humblani on the side because it doesn't. I don't know what's going on. Is that okay?
Yeah, it's fine. It's okay.
Okay, thank you. So now I am back. So we are on what? We are on horizontal shifting. Only the X value will change. The Y value will do what? Guys?
Remain the same.
Will remain the same. So meaning that this point will be what?
From 0
this
to
point.
4.
4. Thank you. From 0. So it will move 4 units. 1, 2, 3, 4. Somewhere here. Yeah. Right? So then this point becomes -4 and 0. There we go. We didn't write this point. Did we write this point? This point becomes
-2 and
-2 and what?
And 4.
-2 and 4. So then our new graph will be like this. Are we all together?
Yes.
Yes, ma'am.
Now let's go to, what was the other graph? H of x equals to x minus 2, isn't it?
Yes.
Yes.
Squared. So meaning that we're still focusing on this graph here, the black graph here. So we are shifting to the right. Remember we said there's a plus here, minus here, but when it comes to shifting, we're shifting it to the right. So meaning that the x value is the only one that is changing. So this will be 0 and, I mean, this will be what? This point will be 2 and 0. So it'll be somewhere here. 2 and 0. Okay. Now we have shifted this point. Let's shift this point here. It'll be what?
It's 4 and 4. It's going to be 4 and 4.
So remember, we still same y value. So this will be 4 and 4. And then now let's shift this point. Let's shift this point.
It will be 0 and 4. 0 and 4.
Thank you. So it'll be here 0 and 4. Then we draw our graph. Yeah, the 4 and 4 is far, guys. Let's assume the 4 and 4 is here. We chose the 4 and 4 very far. So let's assume it's here, 4 and okay. So 4 and 4. Now this is h of x, this is g of x, and this is the original f of x. Are we together then?
Yes.
Yes, no?
Yeah.
And going back. Yeah, it's oh, there I can move it. But it's still frozen. Okay, there we go. Now, use the graph f of x. F of x is equal to x squared to sketch the graph of each function. Therefore, g of x is equal to x plus 4 squared. H of x is equal to x minus 2 squared, right? To graph g, we shift the graph of f to the left 4 units, meaning that the value of x is changing and we're shifting it 4 units to the left. To graph h, we shift the graph of f 2 units to the right, meaning because we are doing a shifting of horizontally, only the x value is changing and the y value is remaining the same. So that is the 2 graphs. Are we together?
Yes.
Yes, ma'am.
Reflection.
Ma'am, I was
Yes?
worried about the graph you drawn. It was cutting the x and the one now.
Yeah, that's what I wanted to ask, because it seems like we have a y-intercepts on the graph that you plotted there.
The previous one.
Yeah, the one.
Remember, it wasn't drawn to scale, right? So then it's not drawn to scale. Obviously, if we can be able to, if we can draw it to scale, then the shifting will be clearer. Like, look at this. You see here, it was drawn to scale. We have 0, then we have 1, we have 2, then we have 3, then we have 4. Do you see the difference? We have 1, we have 2. We were just saying, okay, this point is here. So this point is here. Let's shift it there. This point is there. Let's shift it there. But if you draw it to scale or using a graphing calculator, then it becomes easier to see that it might not cut the what's this the
y.
It might not cut the y-intercept. But this graph is continuous. At some point, it will cut the y-intercept.
Okay.
Because if you draw it like this, you'll notice it continues like this. At some point, it does cut the y-intercept.
Oh, okay.
Do you see that? So here they haven't drawn that because they've drawn it to scale, meaning that between 0 and 1, 2, 3, between 0 and 3, it doesn't cut the y-intercept. But at some point, it will cut the y-intercept. Because look at this. If we have g of x is equals to x plus 4, and you want to find the y-intercept, you say let x equals to 0, isn't it? So then this will be 0, then 0 plus 4 squared, which is 16. It means at 16, it cuts at 16. And 16 is not here. That's why these graphs do not show the cutting, because they're drawing to scale and only ends here at 3.
Oh, okay.
Ma'am, I have a question. When the original graph f of x, when they are saying where is f at x and h at x are equal, that means they are supposed to be at 1 and 1 on this graph. Looking at this graph that is drawn to scale.
Yes. If you're saying f of x and h of x are equal, they are equal here.
Okay.
At 1 and 1.
Okay.
You see, at 1 and 1. And this graph also some points will cut the y-intercept, because remember it's continuous.
Of course.
Yes, because I think here they're just showing that it's actually what's this, when you shifted it, where it would go and whatever, where would it, something like this. But because it's drawn to scale and it's limited on the Cartesian plane from this is -5 and up here 1, 2, 3, 4, 5, and up here it's 1, 2, 3, 3. So they're just illustrating, but if you continue with the graph, it will definitely cut the y-intercept.
Okay, that's clear.
Reflecting graphs. Suppose we know the graph of f. Do you see that it's always, we always start with the parent function, guys? They say we know f of x. Now let's do this. So how do we use it to obtain the graph of y is equals to minus f of x and y is equals to negative x? The y coordinate of each point on the graph of y is equals to negative f of x is simply the negative of the y coordinates of the corresponding point of graph of f of x. So the desired graph is the reflection of the graph y equals in the x-axis. On the other hand, the value of y is equals to minus f of x at x is the same as the value of y is equals to f of x at x. So the desired graph here is the reflection of the graph of f of x in the y-axis. I know they'll take out a small box to do the definition. So the following box summarizes the observation. Now, to graph, remember carefully, to graph y is equals to minus f of x, reflect the graph of y is equals to f of x in the x-axis. Is it clear, guys?
Yes, ma'am.
Ma'am, may you please hide the message at the bottom, ma'am?
Oh, okay. Oh, thank you.
Ma'am.
Okay, to graph y is equals to minus f of x, reflect the graph of y is equals to f of x in the x-axis. Does it make sense? Can you pick it up immediately when you see it? Or you need me to do some explanation and simplify it and take it further down?
And practically you can fold the paper in the x-axis.
Okay. So when you have y is equals to minus f of x, you will know that this is a reflection about the x-axis immediately.
Yeah.
Okay. I have 1 year. Is there another year in a year?
Yes, ma'am.
Ma'am, go over it.
Okay. Now to graph y is equals to minus f of x, reflect the graph of y f of x in the x-axis. Okay. Guys, this is one of the ways I normally used to do it when it was confusing, this reflection and what. I look at this. Ne? I don't care about this. And I don't care about this. Right? I look at what I'm given. Y is equals to minus f of x. Ne? And I'm like, which one is changing, x or y? Which one is changing sign here? I'm moving from y is equals to f of x to y is equals to minus f. Which one is changing?
The y is changing. The y is becoming negative.
So the y is becoming negative, right? So then I go to my Cartesian plane. So I have y and I have x. I know from my Cartesian plane, if the y is changing sign, it means it moved here and came here. Do you see that? Or it moved from the bottom and it went up. What did it jump? The x-axis. Did you see that?
Yes, it won't cut.
Yes, so it jumps because if I'm moving from negative y on top positive y to negative y, it means I'm jumping the x-axis. It means the x-axis become my mirror. Therefore, I reflect about the x-axis.
Can someone please pause his mic?
Are we together, guys?
Absolutely.
Yes, ma'am.
Yes, ma'am.
Now it makes sense, right?
Yes.
Okay. Now, then I came back. Me guys, I used to. Me, if something is hard, I make a plan. Okay. Let's say I don't know what to reflect what and to reflect what. Now I'm given that I have f of x, and now they say f of minus x. Which one is changing sign? The x or the y?
X.
X.
The x. then I go to my Cartesian plane, and I say this is y, this is x. If the x values are positive, I'm here. And I'm changing sign. I come here. What am I jumping? The y-axis. The y-axis is my mirror. So meaning what I did here is the reflection about the y-axis. Are we together then?
Yes.
Yes. Thank you. So what did I sketch the graph of? Okay, they want us to sketch here. So we know f, okay, let's call this g of x. I know that we already have g of x. Why am I doing this for you guys? You do it for yourself. Come on, let's do it. You tell me what to do.
F of x equals to negative x. The parabola is showing downward.
Right?
The first one, the parabola is having a smiley face, not facing downward.
You. So you start with, so this is f of x. They're saying f of x is equals to minus x squared, and they're saying g of x is equals to square root of negative x, isn't it?
Yes.
So where do we start? Let's start with f of x. They want us to graph f of x, x squared. So meaning what is the parent function of this?
It's parabola downwards.
Let's not do that. Remember, I said
parabola that passes from 0.
Thank you. So yes, so we start with x squared. Remember, we need to start with the what's this? The parent function, isn't it?
Oh, okay.
There we go. We start with the parent function because then it's the easiest one. So this is why this is x. So this is the parent function. Now, to get f of x, what we did is we went and multiplied the parent function by negative. So it means what? We are reflecting about what? If you look at this.
We're reflecting about y-axis.
Are we all together,
the x-axis.
guys? There's a y-axis and the x-axis. Why are you saying y-axis? Why are you saying y-axis? Someone has said y-axis. Why?
Because x is our mirror.
Yes.
So,
thank you.
Jumping,
You can't say you are reflecting about the y-axis. You are reflecting about the x-axis because look at this. What is changing? It's y. Y is equals to f of x, and y is changing. Meaning that if y is changing sign, y is moving because y is positive. It's moving from the positive and it's coming to the negative. Meaning it's jumping the x-axis. So the x-axis is the what? Is the mirror, right? So when you take a paper and write this and fold on the x-axis, you'll notice that your graph, when you scratch there, that method that people used to use, I can't even explain it online. Then you see your graph will be like this.
Oh, okay.
Yes. So then this is f of x is equals to minus x squared.
Oh, I got it.
You got it, right?
Yeah.
Thank you. I need 3 yeses, guys.
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, so now let's get g of x. Where do I start, good people?
The original one.
Which is, let's call it L of x again.
Yeah, L of x. Yeah.
Is what?
Goes to root x.
Thank you, root of x. Then we go and sketch it there. Okay. Then now g of x, what is changing?
It's the x value.
So the X value is changing, right?
Yes.
Yeah.
What are we jumping? Which line are we jumping if we're changing the X values?
Y-intercept.
Y, right? Thank you. So Y becomes now our mirror because we're jumping it.
Mm-hmm.
So when we fold it this side, it means it will look like this. Are we together?
Yes, ma'am.
Yes, ma'am.
Guys, make sure you draw it according to scale because you can see I haven't drawn these things according to scale. So it looks exactly like this one, but on the other side. There we go. Are we together there?
Yes,
Yes.
ma'am.
For
Yes,
accurate
ma'am.
measurement, you can use the table.
Hmm?
For accurate measurement or accurate points, you can use the table, but it will take time. It consumes time.
Yeah, but there you'll do it. You see, there you do it when you're doing real life problems and you're solving. But for sketching, as long as it look right.
Okay.
Wait, what? Yeah. But in
Not-
real life, you have to be very accurate. You
Mm.
see here, it's even beautiful.
Wow.
There we go. You see?
Oh, here you go.
Yeah. Hey, I saw something. Domain. I know you saw it already. Domain of X is what? Help me. Domain.
Domain is of a what?
F of X.
Of X is
Isn't it all values of X?
Guys, I'll pinch you.
X
Pinching
must
is
be
not
greater
corporal
than or equals to.
Thank you. I don't think pinching is corporal punishment. I'll pinch you. It only zip. Domain of F. So X is an element of real number such that
X is greater than or equal to 0.
Thank you. The domain is always there in the exam, guys. And then the domain of G of X now is what?
X element of real number.
Such that.
It's undefined, not there.
X is less or equal to 0.
What?
X it is less than equal to 0.
Thank you. Remember we said that we say everything under the square root should be what? Greater or equal to 0, isn't it?
Yes.
So meaning that it's what? Negative X is greater or equals to 0. Divide by -1, divide by -1. X is less or equals to 0. Remember, when you divide by -1 or multiply by -1, it becomes what? The sign changes. So X is less or equals to 0. Are we together, guys?
Yes, ma'am.
Yes, ma'am.
Thank you. Note that the domain of a function is that. We need to breathe again. With vertical, it's something, guys. It says opposite things. So vertical stretching and shrinking. Remember horizontal, what's this? No, this is horizontal means certain thing, but vertical is something. Remember that when we were doing horizontal shifting, we were here like this, and then we went up like that, or we went down like that. Hey guys.
Yes, ma'am.
Yes, ma'am.
When we are stretching and shrinking, ne? Let's say you have a graph like this. Okay. Ne? And you are stretching it. Would it look like this? Or would it be wider?
Wider.
Maybe
If
wider.
you're stretching, you're wider.
Would it be wider or would it be thinner when you're stretching it?
Wider.
Wider.
You mean it will be like this?
Yes, ma'am.
Yes, ma'am.
Yes.
When you're stretching a balloon, does it become thinner or wider? I know we have played with balloons.
Oh,
Wider.
It becomes thin.
No, wider.
Guys, look at the. Let's imagine balloons. I'm giving all of you balloons.
you are
Imaginary
confusing
balloons.
us now.
Yeah. This is a balloon.
You are confusing us.
Why? You have never played with a balloon?
Yeah, me understand it, ma'am.
You have a balloon like this. When you stretch it, your balloon will look like this or would look like this.
The second one.
I'm stretching by pulling or by blowing air inside.
Look at the statement.
It would look like the first one.
The
The one in the middle.
The thinner one.
The thinner one, ma'am.
One.
Are we together, guys? Maybe only ladies played with balloons.
We're not together.
Yes.
Because it's vertical. Remember, vertical, we are dealing with the Y part.
Oh, vertical. Yeah, now we know, ma'am.
So when you have a balloon in your hand, this is your first hand, and this is the other hand, and you have a balloon here, and you pull it like this up. You're stretching it, right? Then it will be thinner, isn't it?
Yes.
Yes.
And then when you're shrinking it, imagine sitting on the ball, it will be wider, isn't it?
Yes.
Suppose we know the graph of, I'm just saying because you need to, it needs to make sense when you are doing it. Suppose we know that the graph of y of f of y is equals to f of x. How do we use it to obtain the graph of y is equals to c times f of x? The y coordinate of y equals to c times f of x at x is the same as the corresponding y coordinates of the function, but multiplying by c. Are we all together, guys?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
now, it's saying multiplying the y coordinate by c has the effect of vertical stretching it or shrinking it. The graph by a factor of c. Are we all together?
Yes.
So now the vertical stretching and shrinking of a graph. C, so we assume C is positive. So they say that to graph the function this over here, why am I pointing with the finger? This graph here, if you are going to choose C greater than 1, then you are stretching the graph of f of x vertically by a factor of 2. Are we together?
Please repeat that, ma'am.
Yes, ma'am.
So they are saying that if you have this, if you're looking for that, it means what you did is you took this, multiplied by a constant c, and assuming that c is greater than 0, meaning c is 2 and 3, it means you have stretched the graph. If you choose c to be 2, 3, 4, 5, 5.5, you have stretched the graph. Now, if you move from here to here, and you chose your c to be between 0 and 1, it means you have shrinked the graph. Are we together, guys?
Yes, ma'am.
Yes, ma'am.
Am I getting the less yes?
Yes, ma'am.
Okay, let's do that one. How many minutes should I give you?
2.
3 minutes. I'm giving you 3 minutes. Let's do it.
We can't see, right?
We can see the question.
I'm back. Did you manage? Guys? Did you manage?
Kinda.
Let's try it. So they're saying you have f of x is equals to x squared, right? And then they want a, where g of x is equals to 3x squared. As usual, we start with our graph, which is like this. Cuts the origin, isn't it? So g of x is equals to 3x squared. So this is y, this is x. So we know that this point is what? 0 and 0. If we choose any point here, let's choose 2 and 4. How do we get a 2 and a 4? It's because when I substitute 2 in here, I get 4. And I substitute -2, I also get what? 4. So -2 and 4. So they're saying that, okay, let's go to the note, back to the notes. They're saying that if C is greater than 1, then it means we are stretching the graph. So meaning that if it is like this, and when you stretch something like this, it will be more thinner. So we should expect our graph to be in here. Isn't it, guys?
Mm.
Yeah, so meaning we
Yes,
expect our
ma'am.
graph to be smaller inside. So let's do that. Let's charge, go here. So let's see if that is true, right? They're saying that you're stretching the graph vertically by a factor of C.
3.
Meaning that here, because g of x is equals to 3 multiplied by f of x, meaning that every y value, guys, mute, every value of y in f of x is multiplied by 3 to get g of x. Yes? Guys, I can hear my voice.
Mute your mics, guys.
Okay, thank you. So meaning that we go and check the y values, right? We multiply by 3. This y value for 0 multiplied by 3 is what?
0.
0. So meaning we are here. Now this y value and the x value is still 2. 4 multiplied by 3 we get
12.
12. So meaning that the point will be here, somewhere here. okay, not really here, but somewhere up here. Let's say here. Right? Even this part, it will be 12, right? So meaning that all the y values, the x values remain the same, but all of the y values are multiplied by the factor 3. So this, if we choose a point here, the y value will go up like that. So if we choose a point here, the y value will be somewhere there. So if we draw this graph, it will look like this. Does it make sense now that when you're stretching it vertically, it becomes thinner?
Yes, ma'am.
Now imagine now pressing the green graph or pressing the what's this, the purple graph. It will become what? Pressing it down. It will become what? Wider. Are we together there?
Yes, ma'am.
Okay. So now
Yes, ma'am.
they say multiply. Let's assume, okay, it's fine. H of x is equals to, okay, let's draw a new graph, guys. I want to choose point where we can easily do it. So now they want us to have h of x is equals to 1 over 3 x squared. This section is long, but we'll be finished now. So we start with the parent function. So y x, and then let's draw the parent function. Now let's say in a parent function, if I choose x to be equals to, x is equals to 3, what do I get? X equals to -3. What do I get? I get y is equals to 9, isn't it? So I'm just choosing points there. So let's say I chose this point, which is -3 and 9. And I chose this point, which is also what? 3 and 9. Are we together, guys?
Yes.
Now they say here, this is the same as 1 over 3 multiplied by f of x, meaning that the y value of 3 I multiplied by 1 over 3. Right?
Yes.
So if this is 9 here, and then the x will remain the same. If I multiply 9 by 1 over 3, what do I get? I get 3, isn't it?
Yes.
Thank you, I get 3. Meaning that I'm moving from this 9 here, the red dots, I'm moving to 3. Let's say 3 is somewhere here. Because I said multiply by 1 over 3, so that will be -3 and 3. So it's somewhere here. Even if I multiply by 1 over 3, 0 times 1 over 3 is still 0. And then this point will move somewhere here. Then if I draw it, you see it will be wider than the original graph because I'm pressing it down and shrinking it. Does it make sense now? So when you shrink the balloon down, it becomes wider. You see, if it was like this, it becomes something like this. When you sit on it, don't sit on it, but like, yeah, put it in your hands and it becomes like that.
Okay.
Yeah. Does it make sense now? The shrinking and the stretching?
Yes, ma'am.
Very good.
Ma'am,
Yes.
I would like for you to please go over it one more time. Especially, I just want to understand. So the coordinates that you picked, those are just random, right?
Yes.
Okay.
Help
And then, okay.
The reason why I picked them is because the 2 and a 4, and then we have to say 4 times 1 over 3. Then we say that is 1 comma. But still, look at this. If I choose a 2 and a 4, here is -2. Isn't that we were working with 2 and a 4?
Yes, ma'am.
Remember, they're not just random. I pick the value of x, I substitute it into the parent function, x squared, and I get y. I pick the value of x this side, I substitute it into a parent function, I get y. So if then they say the y value multiplied by 1 over 3. So if I multiply 4 by 1 over 3, I'll get something like 1,333, right? Let's say that. So then it means I'm moving from what? I'm moving from 4 here, and I'm going to 1,33. 1,33 will be somewhere here, which is here. And then remember, only the x value is changing. So this will be -2 and 1,3. Even this side, this will be what? 2 and some 1,3. This point moves from here. So then you draw your graph like this.
Oh, that's where C is less than 1.
Yes, where C is less than 1. Remember, we're saying that y is equals to C times f of x. So C is less than 1. And you notice if C is less than 1, it reduces the value of y. If y was 4, any number less than 1 will reduce, multiply by 4, between 0 and 1 will reduce, it won't increase it. You see, and then any number greater than 1, it will increase it, it will take it here. That's why it's what? It's stretching it.
Oh, yeah, I understand.
Yeah, and it makes sense. If you increase the pressure of pulling, you are stretching it so it will look thinner, vertical. Do you understand? So if you then release it or you go down to between 0 and 1, then it will, what's this? It will be more wider. Yes.
Oh, understandable.
Thank you. So here they're showing you that you're stretching it, and here you're shrinking it. So the graph of G is obtained by multiplying the y coordinates of each point on the graph of f by 3. That is, to obtain the graph of G, we stretch the graph of f vertically by 3 factor. Anything that is vertically, it's easier to do, but you need to be careful when it comes to horizontally. You need to make sure you understand it properly. There we go. Do you see that, guys? Don't worry, we are done. The graph of H is obtained by multiplying the y coordinates of each point by the vector of 1/3. That is, to obtain the graph of H, we shrink the graph of F vertically by 1/3. Okay, I don't know what they're saying. The result was the widest. The result is the widest parabola. Here we need to breathe as well. Horizontal stretching and shrinking. Now we consider the horizontal shrinking and stretching of the graph. So it says, if we know the graph of y is equals to f of x, then how is the graph of y is equals to c times x related to it? The y coordinate of y is equals to c times x at x is the same, yes? Are you talking, yes?
Oh, I say the y coordinate of y into f of x, c f x.
Yes. So they're saying that here, this is a point. The y coordinate of y is equals to f of x, f of cx at x is the same as the y coordinate of y of f of x at cx. Are we all together there? So meaning that the y coordinates according to this is not the one that is changing, isn't it?
It's changing x coordinate.
Thank you. That's the x coordinate in the graph of y equals to f of corresponds to the x coordinate in the graph of y is equals to multiply by c. So they say, looking at this the other way around, we see that the x coordinates in the graph of, right? They're saying the x coordinates in the graph of this are the x coordinates in the graph of this multiplied by that. Does it make sense, guys?
Yes, ma'am.
Looking the way around.
Can I please have 3 yeses?
Yes, ma'am.
Oh, yeah. Got it.
Yes, ma'am.
My ladies, where are you at?
The ladies are sleeping.
Thank you. They're not sleeping. X coordinate. Okay, so meaning that they're saying, looking at this the other way around, we see that the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates in the graph of this, are the x coordinates multiplied by 1 over c, meaning that we will take the x coordinate of the original function, multiply by 1 over c to get the new x coordinate of f of c of x. Does it make sense?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Thank you. In other words, we change the graph of to the graph of, we must shrink it. We shrink the graph horizontally by a factor of 1 over c if c is greater than 0, as summarized in the following block. So, to graph y is equals to fcx, if c is greater than 1, shrink the graph. To graph the graph of y is equals to c f of x, if c is greater than 1, stretch the graph.
Vertical.
Guys, do you see something here different between vertical and horizontally?
Yes, ma'am.
Thank you.
Yes, ma'am.
So don't say if c is greater than 1, then you shrink and you shrink. Check vertically and check horizontally. Because vertically says, if you're multiplying f times f of x, if c is greater than, then you're stretching the graph vertically by a factor of, there. Go back here. Horizontally, we are saying that if c is greater than 1, then we are shrinking the graph of horizontally by a factor of 1 over c. Are we together, guys?
Yes, ma'am.
And then if c is between 0 and 1, then stretch the graph of y horizontally by a factor of 1 over c. Are we together?
We are together, ma'am.
Okay, let's go back to the statement. Looking at this other way, around c, we see that the x coordinate in the graph of y is equals to f of cx. Are the coordinates, are the x coordinates of the graph this? Multiply by 1 over c. Since we said we are together, let's do this one.
Okay.
Can we do this graph, guys?
Yeah.
Okay. Let's try to do it. Or no, let's not do this one. Let's do fy, the easy one, f of x. So y is equals to x squared. Let's do that one. Are we together? F of x is equals to x squared. Let's try to do that one.
We are using the parabola.
Yes, let's use the parabola because I want you to sketch it.
Not absolute value.
I want you to sketch it. Let's sketch that, guys. At 13:30, oh, we've passed so much time today. We need to finish this section. At 13:36, guys. I mean 37. Let's think about it. And remember here, they say the y value is not changing, only the x value is changing. Are you ready to discuss, guys? Yes, no?
We are ready now.
Okay.
Yes.
Okay, now we say the y values are not changing, eh?
No. Yes,
okay, let me go to the nodes. I want to come to the nodes because I want the statement. We said we're using the parabola, okay? Now, let's read here. You see they're saying that if c is greater than 1, shrink the graph of y is equals to f of x horizontally by a factor of 1/2. If you shrink it, it will be thinner, isn't it? Look at this. And if you stretch it, it becomes wider. And then if c is greater than 1, we expect our graph to be shrinked, right? Horizontal, it means thinner. But if c is between 0 and 1, we expect it to be wider. Okay, good. Now let's go back to our Word document. So this is the graph. Remember, we start with the parent function, yx.
Yes.
Now they are saying that what is g of x times 2x? Okay, let's choose point. Remember, I always choose the turning point. For me, it's 0 and 0, right? And then we have
negative 2 and 4.
Negative 2 and 4.
Negative 2 and 4.
And then 2 and 4. Thank you. So what do you think will change here? Hey guys, let's make it
The
x.
X
Okay. I want us to make it a little bit bigger so that we see the difference. So this is y, this is x. So our parent function is this one. So this is x squared, y equals to x squared. And then you chose 2 here. And then you take 2, you substitute into the parent function, you get 4. You choose another 2 here, negative 2. You substitute in x squared, you get 4. Now, g of x. Okay, so 0 is 0 here. So, can please help me? With g of x, the values of x will be what?
Will be negative 1.
Negative 1.
And 1.
And what?
Oh, man.
1 and 4.
No, man.
Only 1.
It's negative 4 and 4.
Negative 4 and 4. I told you that when it comes to horizontal, you need to breathe.
Yeah.
Man, we are breathing. Man, it's negative 4 and 4.
Okay, negative 4 and 4. I know someone, okay, me, I don't have an answer. Someone has a different answer. Negative 4 and 4.
Yes, ma'am.
Yes, ma'am.
All agree?
No.
We all agree.
And there's a no. Me, when there's one no, it cancels everything. Ah, why no?
I think it's half and 4. Negative half and 4 and half and 4.
Half and 4 and half and 4.
No, what do you think for the G of X, ma'am?
It's going to be 0 and 4.
0 and 4.
Yes.
Because you're giving me answers and you're giving me good reasoning for your answers, but all the answers,
Ma'am,
they're not the answers.
It's negative 4. It's negative 4 and 4, ma'am.
Hey, why?
Ma'am, because we are stretching the graph.
Where?
Horizontally.
So that means that we are stretching it horizontally, ma'am. That means that the X values are going to change.
Okay. You're saying it's negative 4 and 4. Let's start there. Negative 4 and 4. It means it will be here somewhere, right?
Yes, ma'am.
Yes, ma'am. And then another one will be
It's
what
4.
here? What would be this point?
4 and 4.
4 and 4. And this point will be what?
0 and 0.
Okay, I'm drawing this.
The origin remains. We're drawing it, ma'am. Yes, ma'am.
I'm drawing it, right?
Yes,
And
ma'am.
I'm going to my notes. Okay, so if this by looking at this, is this graph shrinked or stretched?
This graph is stretched, ma'am.
Stretched.
It's shrinked, ma'am.
If C is greater than 1,
ma'am,
the graph of Y horizontal by effect of that. So it means that you guys have stretched the graph. So you are wrong, isn't it?
Oh.
Yes.
Oh, we
we
are
are.
wrong. Oh, we are wrong.
Me, I'm just giving what you're giving me. Okay?
Sorry, ma'am.
Thank you. Let's
It's
go back to the
negative.
notes for the. Let's go back to the notes for the last time. If C is greater than 1, shrink the graph of Y is equal to f of x horizontal by a factor of 1 over C. Now I'm going to vertical. Remember I said with horizontal you need to breathe because C is greater than 1. That is vertically stretch the graph. When we are vertical, we are stretching the graph if C is greater than 1. When we are horizontally, we are shrinking the graph if C is greater than 1. So let's go back one last time because we need to go to the next section. If C is greater than, we shrink the graph of Y is equal to f of x horizontally by a factor of 1 over C. Now, someone tell me. We said
It's
the purple one is
-1 to
wrong.
4.
Minus?
Minus 1
1
to
and
4.
4 and 4.
And then?
And 1 and 4.
And 1 and 4.
Yes, 1 and 4.
And then?
It's not
0 and 0.
And 0 and 0.
Does this look nicer now?
Yes, ma'am.
But does it make
Yes.
sense?
It does, ma'am.
Actually, it does.
Okay, so they are saying that this is what they did. Is there someone who wants me to explain or pass because I'm over hours now. I just need to finish the section.
Can you explain?
Can you please explain?
Yes, explain.
Because the note says, I need to go back. You said you understand that part. Come here. Looking at this the other way around, we see that the x coordinate of f of cx are the x coordinates of the graph of y, f of x, ne? Multiplied by 1 over c. Does it make sense now? It means that I'm going to take the x values of the original, multiply by 1 over c to get the x values of that. That's what they are saying here. Horizontal by a factor of 1 over c.
Which is negative half and 4 and half and 4.
Let's go back. It means that for me to get the values of this one here, I have to take the x values of this. Remember the x value is that, right? For g of x, the x value will be x times 1 over c. In our case, c is what? Is 2, isn't it?
Yes.
Yes.
So then it's x times 1 over 2. Now our x here at this point is what? Is negative 2. So it's negative 2 times 1 over 2, which gives us negative 1. That's why we got negative 1. And remember, only the y values, it was supposed to be here. Only the y values remain the same. So the point was supposed to be here. So it's what? Negative 1 and 4. And then this point here, the x is what? The x is, what is the x here? It's 2, right? Then you say 2 times 1 over 2, which is 1. Meaning that the point will be somewhere here now. Right? But the y value still remains the same. So the x value, this is 1. This is 1. Initially, it was at negative 2. And initially here, it was what? At 2. So the y value remains the same, but the x value changes. And this one the same. So 0 times half is equals to what? Is equals to 0. That's why it's the inside graph.
Okay.
Are we together now?
Yes.
It's string.
Yes, ma'am.
Yes. Thank you.
Shrink inside the original one.
Say?
I mean, it shrink inside the original one.
Yes. So it makes sense. That's why I'm saying, look at it if you have a balloon. If you're shrinking it horizontally, it will be thinner. It's like you're praying. You put your balloon in the middle of your hand and you try to pray. You know, when you pray, you press the balloon like this. It makes sense. It'll be like this. But if you pull it right across, it has to be wider. And they're saying that if C is between 0 and 1, then you are doing what? You are pulling it. So now you see that our C is half. It means that our graph, we're assuming our graph will be outside the original graph. Let's see if that's true. That's what I'm saying with math, you can see by Justin G, the statements. So we have y, we have x, I almost wrote x here. It's
the original graph.
The original, the parent function. Choose values. Me, I like choosing values where you see there, it said h of x. Is it h of x? F of x? What do you call it? This one. Let me see. It's f of x half. So they say h of x is equals to half of the original graph. Me, I normally like choosing. You see, it's a half here. Which number is easily divisible by half? Oh no, let's not do that now. Okay, give me points, guys. 0 and 0 and
2 and 4.
Negative 4 and 4.
It can't be negative 4 and 4.
Negative 2 and 4.
Negative 2 and 4. Because if you choose x to be negative 4, then you substitute in x squared. Then that will be 16. You don't just choose point. You choose the value of x and go substitute in x squared to get the value of y. And then here we have 2 and 4. So let's go to our notes. And it says that if c is between 0 and 1, you stretch the graph of f of x horizontally by 1 over c. So this is 1 over c, guys. Sorry about that, but this is 1 over c. Are we together? So meaning that if we are stretching the graph by a factor of 1 over c, what is our c in this case?
C is half.
C is half. So if we are going to multiply by c, and they say we need to multiply by 1 over c, this becomes what? 1 over 2. It becomes what?
2.
Right? So then go take the x value and multiply it by 2 now. So that will be -2 times 2. It becomes -4. It means that your y value remains the same. So that is the y value. But your x value changes to 4. So it'll be somewhere here. Let's say this is -4. So this will be what? -4 and 4. And then here, it's still 0 and 0. And then here, it will be what? It will be multiply 2 by this 2 is 4. So it's 4 and 4. So it'll be somewhere here. 4 and 4. Then that's your graph of h of x. This is f of x, the parent function. Are we together, guys?
Yes, ma'am.
Yes.
Yes, ma'am.
So with the vertical, you need to breathe. Just understand it, and then you'll be fine. You'll see here, when you shrink it, it'll be, so here you see it means you are shrinking. So when you're shrinking, you're expecting something like this. Like this, isn't it? They'll be closer like this compared to being wider, right? If you're stretching it, they'll be more wider. This will be more wider. Let's see. If you put your hand here and here and shrink it, you see it makes sense. And if you pull it, it makes sense. The string even. Are we together, guys?
Yeah.
Yes.
Yes, ma'am. I'm tired. So even in function and odd function, I'll be very quick. If a function satisfies this, then for every x, for every number of x in its domain, then the function is even. Are we together? Guys, are we together or
Yes,
not?
Yes.
Yes, ma'am.
So for instance, if I take a parabola and substitute any value of x in parabola, I will always get a positive value. So then it means that a parabola is what? Is even. So now note that the graph of an even function is symmetric with respect to x, meaning that if I draw just half of it and fold a paper and draw on top another half, they're saying it's symmetric about the x-axis. It's just the mirror image. That's what they're saying. Are we together?
Yes, ma'am.
Good. This means that if we have plotted the graph of f for only x greater than 0, that means from here only, this part, if we have plotted only this part, then we can obtain the entire graph by simply reflecting it, the other portion in the y-axis, as we said, this part. Then we can do reflection. If f satisfies f of negative x like this, right? For every number x, it's in its domain, then f is called an odd function. For example, a cubic function is an odd function, right? So here they give you an even function and odd function. They didn't say anything about reflection. Okay, they would say it somewhere here about symmetric. So they're saying that if f is even, then if you substitute a value of x in f of x, you'll always get the original f of x. And if f is odd, if you substitute any value of x in f of x, you'll get a negative of f of x at some point. Then the function is what? For every value of x, then the function is odd. Now they're saying the graph of an even function is symmetric with respect to its y-axis, meaning that it's symmetric here. This side is the mirror image of that side. The graph of an odd function is symmetric with respect to the origin. So meaning that this half is exactly the same as that half when you reflect it about the origin. Are we together?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Thank you. In the exam, I might give you this and state whether it's an even or odd function, or I might actually give you the graphs and tell me whether it's an even or odd function. So they say determine whether a function are even or odd or neither. So let's see. A, for me to check if it's even, I need to check that negative x is equals to f of x. For me to check it's odd, I need to check negative x is equals to negative f of x. So let's see. So let's put a negative inside there, and then we get negative x to the power of 5 plus negative x. You see that this is, okay, so this becomes negative x to the power of 5, negative x. If I take out the negative 1, so I'm remaining with this, then we have x to the power of 5 plus x. And you can see that this is negative. This is what? F of x. So meaning this function is odd. Do you see how do you prove even or odd?
Yes, ma'am.
Right?
Yes.
Thank you. So let's look at B. B, you have g of x equals to 1 minus x to the power of 4. Negative gx is equals to 1 minus negative x to the power of 4. So this is equals to 1 minus, because it's even this one and you square it like that, to the power of 4. So this becomes positive x to the power of 4. So this is exactly the same as g of x. So this is even function. Are we together?
Yes.
Now
ma'am.
number C,
Yes, ma'am.
we have h of negative x is equals to 2 minus x minus x squared is equals to minus 2x minus x squared. And even if we can take out the negative side, it will be negative 2x plus x squared. And we can see this is not the original function. So this function is not even and is not odd. Yes?
Neither even nor odd.
Yes. Thank you. So I think they're giving the answers there. That's exactly what we got. I know we are tired, but now can we combine everything we have learned? One last few minutes. Yo, from 11. Hi, guys. Draw f of is equals to 1 minus 2 x minus 3 squared. Please draw that with transformation. Then we are done for today. Guys, have you tried it? Guys?
Yes.
Hello?
Yes.
Okay, yo, we've done 3 hours today. I see I'm so tired. But let's do this one.
Okay, let's do it. Then.
You say?
Let's go for it.
Okay, let's go for it. Did you hear that? Let's go for it, guys. Where do I start?
We start by simplifying
the parent function.
Parent function. We don't simplify anything. Parent function. Let's call it so that is x squared, isn't it? Don't simplify. X squared, ne?
Yeah, x squared.
Yes, ma'am.
Let me make space. Now we're starting to even answering some of the exam questions and the assignment questions. So this is y, this is x. So I start with the parent function. Then what do we? Guys, I'm waiting for you. I know we are tired. We're just doing this one and then we are done. We're combining everything that we have learned. This is a parent function. Guys?
So I think we have a graph to the
point. Thank you.
To the right.
Yes, which is 0 and 0 and negative.
And then?
Negative 2 and 4.
Negative 2 and 4. And then?
And 2 and 4.
2 and 4. 2 and 4. Thank you. So meaning we have drawn this part. Where do we start now? So this is h of x squared. What do we do next? You can start with any transformation you want.
Can we from that graph because we can see that it has shifted 1 unit up, ma'am.
You can do that.
Yes, ma'am.
Okay, so let's do that. Okay. Okay, let's do shifted 1 unit up, ne? So meaning we are covering this part. So our green graph, let's call it g of x, is equals to h of x plus 1. It means it's x squared plus 1, right? So when you're shifting up, which value is changing?
The y value.
The y value. So meaning that this will be 0, 0 and 1. And this will be negative 2 and 5. Let's say 5 is here. Negative 2 and 5 is here. And then it will be somewhere corresponding to this one. See. Are we done? So this is g of x. This is only this part. Okay, then what do we do next?
The graph needs to shift horizontally to the right 3 units.
So you're saying what?
3 units to the right.
3 units to the right.
Okay, so meaning that we are taking, let's call this r of x. We are taking g of x and shifting it 3 units to the right. Sorry. So it will be written like this. Okay, let's call it here. R of x, we are taking g of x and shifting it 3 units. Is it to the right? Yes, to the right, minus 3. So then this will be equals to x squared. What am I saying? X minus 3 squared plus 1. That's how far we have done, isn't it? Okay, so we are here. Let me choose a different color. We are shifting it to the right. So if we are shifting it to the right, which value is changing, the x or the y?
X.
Okay. So this, we know the y value is 1, and this is 0 and 1. So it will be what here? With the point here, this point, where is it going to go? What will be the point?
3 and
0 and
3,1.
3 and
3 and 1.
3 and 1. Thank you. So let's say 3 is somewhere here. So the x value is 3 is here, the 1 is here. Okay. Now this value here, what it will be?
5 and no. 1 and 4.
1 and 4. Okay, we didn't write
Yes,
these
ma'am.
values, guys. We said from here we shifted it up, ne? So this became what? -2 and 5. Isn't that we need to write the point so that we can do the shifting? -2 and 5. Because it went up 2 and 5. Remember, it went 1 unit up. So we moved from here, we came here. Yes, we moved from here, we came here, we came, yeah. So now we are saying we're shifting 3 units to the right, isn't it?
To the
So
right.
this is 0 and 1. So this
Yes,
becomes 3 and 1, isn't it? So the x
Yes,
value is
ma'am.
the one changing. Now this one becomes what? What does this point become? This point,
1 and
-2
5,
and
ma'am.
5. 1 and 5.
1 and 5, ma'am.
Thank you. So the x value becomes 1 and 5. So 1 and 5. And then this point becomes what?
5 and 5.
5 and 5. This is 2 and 5. How does it
Yes.
become 5 and 5?
Yeah.
You add 3, ma'am. So
Oh,
it's 5 and
sorry.
5.
5 and 5. Yeah, you're right. So it becomes 5 and 5. Let's say 5 is here. So 5 and 5 is here. So then the graph is like this. Now, do you see that? This
Yeah.
is the graph of R of
Yes,
X.
ma'am.
Yes.
The R of X is what? Is x minus 3 squared plus 1. Now let's call this h of x. What is the new h of x? What can we do to the graph? Guys, what can we do to R of X so that we get the graph?
Yeah, I think we expand by 2.
Okay. We expand how by 2?
Because there's a 2 that is outside. 2 said, I think you must expand or shrink by 2.
Okay. So then when you multiply by 2 outside here, what do you do?
My -2.
Guys, we can't multiply by -2. We can't multiply by -2.
We add by 2.
You know why I'm saying that? Because you need to take step by step. So what do you do? Guys? And we might have started the whole transformation not nicely, because then it will give us a problem. I'm foreseeing a problem here. I don't know if you see it with me. Guys? Hello?
Yes, ma'am.
Ma'am.
Yes, ma'am.
Can you see the problem with me? Yes or no, guys?
Yes.
Oh,
I think the way we have started it might not be the ideal way of starting it.
Yeah, I'm also getting confused.
Yeah, because look at this. Okay, let me do it. Let me do it how I would start it. So we have f of x ne, is equals to 1 minus 2x minus 3 squared, right?
yeah, we put it in
I
the
think,
first form.
yes, let's not start with shifting it. You see this part? Let's not start with that part. Let's start with this one. Then it will make our life easier. Are we together?
Yeah.
Yes.
Yes.
Because if then you have f of x is equals to x squared, right? what will happen is you'll have something like this. This is the parent function, right?
Yes.
And then you say, okay, fine. What I can do is, you can either do whatever is inside, or you can multiply by 2 first. Do you see that? So let's call it this g of x, and multiply by 2 and x squared. Do you see that?
Yes, ma'am.
Guys? And if you multiply by 2, okay, let's put points. So this is 0 and 0, and this is -2 and 4, and this is 2 and 4. Now, what values are changing here? What are we doing here? Do you see that we are stretching or shrinking vertically?
Yes.
Guys?
Yes, ma'am.
Right? So meaning that from here, where we see the y value, we multiply by 2. So the x value remains the way it is, but the y value will change. So meaning that multiply by 2, this will be what? This will be -2 and 8. Multiply by 2, still 0 and 0. And this multiply by 2, this will be what? 2 and 8.
Yes.
So meaning that our new graph will be like this. Are we together, guys?
Yes, ma'am.
Yes,
Now,
ma'am.
if you take g of x and find L of x, for example, and you multiply with a -1 here, g of x, what are you doing there with this negative? What are you doing there? From what we have learned.
X is changing.
It's x. What is this? Not x is changing, but which one is changing?
Y axis.
And when the y is changing sign, what are you doing? Remind me. What are you doing? You are reflecting about what?
X-axis.
X-axis. Meaning that your red graph comes like this.
Sure. No.
Do you see that? So then this
Yes, ma'am.
becomes what? -2 and -8. This becomes 2 and 8 from the red graph. Do you see that from G? Because then L of x will be equals to -2x squared. Meaning that we are covering this -2 here. Do you see that? Guys?
Oh,
Yes.
okay.
Yes.
So put the function f of x into the ordinary function, like a f of x equals to -2 into x minus 3 squared plus 1.
Wait, if you do what?
I mean, like to put the f of x function into order form, like f of x equals to -2 into x minus 3 squared plus 1.
Yeah. No. Remember, we can't do +1 right now. We are reflecting. We are taking bit by bit. You see, we started with x squared. Ne?
Oh, okay.
And then after x squared, we multiply by 2. We got 2x squared. And we know that from what we have learned, if we multiply by 2, we are stretching the graph vertically. That's why it's the red graph, right?
Yeah.
And from our original equation, we know there's a -2. That's why we multiply by, we take this one, we multiply by -2.
Okay.
You see that? Meaning that we know that if you have y is equals to -f of x, then we, according to this negative, we are reflecting about the x-axis. That's why we have our new graph now.
Okay.
Do you see that? Now we move from here. Let's go back. So there's an x minus 3. It means that we move from here. And now let's call this v of x. From here, we have -2, and then we put that x minus 3 squared. It means that From this graph here, x minus 3, we have to shift to the right 3 units.
Mm-hmm.
Do you see that?
On the x-axis.
Yes, because this now we are shifting this purple graph. This purple graph is this one. So we are shifting this graph 3 units to the right, meaning this point will be what? 3 and 0. So it'll be here. 3 and 0. This point here will be 1 and negative 8. So it'll be somewhere here. 1 and negative, sorry, here. Let's say 1 is here. So it'll be 1 and negative 8. Now this point here will be what? 5 and negative 8. So the new graph will be like this. Are we all together, guys?
Yeah, I got it.
So meaning that this graph here is the graph of v of x is equals to minus 2x minus 3 squared. Now, are we done? No. Why are we not done? Because there's a 1 here.
We shift it down.
So meaning that, but then it's positive 1. You can't shift it down. It's positive 1. It means you have to shift it
Upward.
upwards. So when you shift up, what value changes is the y value, isn't it? So here, this point will come here. So this will be 3 and 1. This point here will shift 1 unit up. So it will be from negative, from 1 and negative 8, it will be 1 and negative 7. This point here, from 5 and negative 8, it will be, comes here. It will be 5 and negative 7. Then that's your new graph. Did you see how I went, guys?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
let me just summarize it. It means that because if you start shifting anyhow, it will give you a point. A problem at some point. So what I said, I had f of x is equals to 1 minus 2 of x minus 3 squared. That's what I'm saying. I started with h of x. And I said, oh, this is x squared, a parent function, right? I changed h of x into g of x is equals to, what's this? H of x, I multiplied it by 2. Then I know I'm what? I'm stretching the graph. So then it became 2x squared, right?
Yes.
So I drew this one, and then I multiplied by 2 because I see a 2 here. And then I drew this graph. After that, I took this graph and formed, let's say an r of x. The r of x, you see there's a negative here.
Yeah.
And then I multiplied g of x by a negative. And according to what I've learned, if I multiply g of x by negative, it means I'm reflecting this graph that I've drawn here, the g of x. I'm reflecting it about the what? The x-axis. Then this becomes negative 2x squared. Now that I'm done with the outside, I take now this r of x that I've drawn, right? I then shift it 3 units to the right. It means let's call it v of x. Then it becomes 2. So what I did is I took r of x and then I shifted it 3 units to the right. So this means it becomes negative 2x minus 3 squared. Then I drew this v of x. After that, what is remaining? I see, okay, fine, now I have everything except for this 1 here. So how do I get the 1 here? It means I have to shift the remaining, the v of x, let's call it p of x. I've taken the v of x and I've shifted it 1 unit up. It means I added a 1. So then we have 1 minus 2x minus 3 to the power of 4. Are we all together now?
Yeah.
Yes.
Yeah. I think we can stop. Yeah.
2 minutes.
Let me stop the recording.
Yes.